This conference will now be recorded.
And openEDGE has been disassembled, so we can look at some. Notice that. You can look at all of the pieces.
All right. Has everyone had a chance to take a look at openEDGE, understand the concepts, or would it be good to go over a brief overview to kind of get everyone level set?
Let me ask one question, Mike. We have an openEDGE weekly and monthly call. How many here in this room have participated in one of those calls? Or how many are here for the first time kind of hearing about this? How's that? Okay, so quite a few. That's great.
Mike's outside. So before Mike gets started, 2 or 3 housekeeping things. One is if you want to get on the Wi-Fi, which I'm pretty sure everybody does because they have a laptop here, there is I think it's called the NUQ guest, and you can use Mike's email, Mike.org.
Actually, there's a little banner that is going around on how to sign up for it.
Right, but it asks you for an email, right?
It has the
Okay,
email.
perfect. So use that sponsorship email if you need to get on it. And then you were going to talk about.
Yeah, well, for the benefit, can I spend 5 minutes, Mike?
Oh yeah, absolutely.
To kind of set the stage. There was probably 2/3 of people are new to this.
We have 6 hours.
Got it. Okay.
Okay. We have till 4 in the afternoon, so
okay.
I think we have plenty of time.
So let me try to give everybody a little bit of a quick history lesson. So the Open Compute project is all about improving cloud efficiency for all cloud operators around the world. And the idea is to share a hardware design so that everybody can leverage those designs as much as possible, reuse those and innovate on top of it. And so we've been in existence since 2011, and we have we don't have an architecture that we support. We support and encourage our community to really kind of work together and figure out the best solutions. And so recognizing that there's many solutions that that represent the portfolio of products that are necessary around the world. And so a lot of times people kind of open compute with the original Facebook contribution, which was the Open Rack architecture. But we also support the standard EIA 19-inch product and a lot of other variants. The whole idea is that whatever we do, we want to drive efficiency and scalability and openness and be impactful to the cloud industry. A few years ago, what we saw in the telecom space is as the carriers re-architected their infrastructure as a data center, they adopted data center-like products, and so that was widely adopted in their regional data centers. They basically operate their regional data centers as a cloud data center, and whether their applications run on bare metal or run as a virtual instance, it doesn't matter. The underlying hardware is exactly the same. And as they grew that and evolved that infrastructure, those same types of things occurred in the central office, where they were installing cloud hardware in their central office to run those same applications. Not just your traditional servers and storage devices, but also all of your network appliances. So as the cloud industry evolved around the disaggregation of network appliances and the evolution of 10 to 25 to 100 to now to 400 gig, the telecom industry has been able to draft behind that, adopt those standard switches, commercial silicon, standard open source operating systems for the network switch, as well as all the various DPDK and network stack components that sit onto that. And so the whole industry's been able to really accelerate adoption, accelerate that technology off of these building blocks. And specifically to the telecom industry, they've been able to do the same thing with because of this disaggregation, they can quickly evolve their passive optical network interfaces, their OLT devices, and other interconnects that they have traditionally had in the central office and at the edge, and so they're able to quickly spin that those devices and evolve that, and now they've really adopted an infrastructure built around these disaggregated network switches, and it makes only sense to do the same thing with the server technology that sits and is connected to that equipment. So we've seen this happen for the last few years, and we back up these observations with market research that the Open Compute Foundation invests in. We did market research a year ago, and we just finished up another market research project to understand how these transitions are occurring. And a year ago, it said, hey, the industry is going to really, is probably the highest growth industry or highest growth segment for open hardware, white box hardware, open software solutions. And so they made some estimates on that, and it was pretty it basically said we should all get in that business because it's like a 100% CAGR type of growth. Now the numbers are very small, but they came back and redid all those numbers just recently and republished that back to the foundation, and we'll share that at the summit. But it said actually they underestimated that growth and that opportunity. It's probably bigger than what they thought. But if you kind of dive into those details, your takeaway should be that not only are we kind of on the front end of that, but there's a lot of things that we got to do to really make that happen. And one of them is, we have to have a supply chain that could, deliver solutions. And two is we have to have, the right products. And so in the networking space, there's a lot of things that are going on. But in the compute side, we needed some standardized platforms and standardized products. And we now are starting to see the carriers adopting, this open rack architecture, which is an OCP architecture, and as well as the Microsoft Olympus architecture, again, another OCP contributed architecture. So we're really starting to see that kind of, start to kind of get some footholds in POCs around telecom companies, around the globe now. But as they kind of grew from the data center to the CO and then eventually to their edge, they wanted to have a uniform solution. They wanted the same hardware, the same, manage it as one, very large infrastructure with kind of monolithic set of tools, and reuse as much of that as possible. The problem was is at the edge, you go into a harsh environment, or you go into an environment that has space constraints. And, it could be in a factory floor, it could be, in a central office, but it may be at the base of a radio antenna. So it may be picking up, IoT devices and through Wi-Fi connections out in the middle of the city somewhere in the metropolitan area. So a lot of different types of installations, and that traditional piece of hardware that went into the data center wasn't the right physical architecture, wasn't spec'd out, to correctly, and honestly didn't need to have all the power that we had in the data center, but it needed to have some opportunities to do some very specialized I/O and to drive latency sensitive applications to go host those down the wire and remotely install and update and program those. So we were seeing that as an organization. Nokia, we've seen that as a supplier to that organization. Other partners, AD-Link, was seeing that as well. And we started this conversation probably a year ago that said, gosh, we really could stand to have a uniform enclosure, a uniform product. So you look across the landscape, and there's a lot of edge devices from a lot of different companies. And the feedback that we got through IHS Markit is that the carriers don't want a proprietary solution. They want a solution that is multi-sourced, that they have some assurances of business continuity. They like the concept of openness. They like the concept of OCP, but they want to buy it from one company that can do all that integration. And so the notion of having a standardized edge box just made a lot of sense. And it takes all these other edge boxes, and I don't know how many different variants, or I'm going to guess there's probably 6 or more different kind of variants. It's my opinion, and I think other people share this, is that, we're not going to the industry's not going to make a big dent in the transformation of these edge devices if we have 6 or 8 different designs, all competing against each other.
You may want to define what an edge. There's so many different edge, so maybe
the
edge for this one is, like at the radio tower.
Yeah, I'll get to that. So we said we really have to have some standardized platform, and so with the work that Nokia did, the market research did, and kind of, other people were kind of saying, I think that's the right thing, is that, you want to use that data center hardware that you're using in your regional and CO as much as you can, but it doesn't always fit. So what do you need on the edge? Well, it had to be small, had to go in a harsh environment, had to have options for power and cooling, and it had to likely fit into some other, type of enclosure that's a hardened enclosure. And so depth was a concern, overall size was a concern, and also how it gets mounted into a device, as well as it had, because the types of functions that are being performed at the edge can vary widely, from content delivery to I/O capture to some of the 5G control to you think about VR and autonomous driving, and so these really low latency applications you have to make less than 10 millisecond decisions, turnaround times on. So you had to probably have some hardware acceleration capability and so on in there. And that hardware, even that hardware acceleration, had to be flexible, because there could be so many different variants of that, with 45 different companies out there today that are making hardware accelerators. So you had to have the ability to kind of respond to that market. So the notion of having a generic enclosure with that we could quickly configure just made a lot of sense and brings the industry together. So so Nokia offered to as a starting point, is to say, hey, we have a Nokia designed enclosure. It captured many of the attributes that appeared to be the right attributes in terms of depth. There's some depth limitations in these where these things are installed. It was captured that in terms of the flexibility to quickly add different devices into it, to be able to figure out how to deal with different power inputs. It kind of captured that, and by sharing that enclosure, it allows the whole community to embrace that, design around it, and innovate within that enclosure, and ideally not impact their business, and really build a business around these common modules. From a supplier perspective, it said, hey, I kind of have a target type of device that or enclosure I can design to. From an integrator's perspective, it says, hey, I probably have a pipeline of product that I can use and build solutions with. As a manufacturer, you take advantage of all those partnerships when you bring it together. A couple other things. It used the NIC 2.0 standard was one of those I/O options. I don't know how many millions of cards that are shipped, but I think every company sells a NIC 2.0 compliant add-in card now. It is the de facto standard. There has to be 10, 20, 30 million of these cards sold a year. We don't know the numbers, but it's pretty big. So it's anyway. That was kind of one of the key features. So that's how this project came about, and so it was late Q4 when was it, Mike? We kind of formally kicked it off. October, November.
Yeah, the actual announcement was made last March.
Was it?
OpenEDGE platform, and our intent contributed to the OCP. Yeah, and then it was, I think, October.
I think we actually created a project called openEDGE.
It was right after the Amsterdam Summit.
Right.
Yeah. Okay. So that was in October 10th or something, and that was, I think, right after that we said, okay, we're going to kick off this project, and the idea is to onboard as many companies as possible, and use this as a building block and an opportunity to evolve it. So, the workshop today is really understand, what this building block enclosure is, and provide feedback on how do you use it, what do you need to have change, and recognize that like any building block, it evolves. All of our standards in this space have evolved. We started off, even with OpenRack in 2012, it's gone through one major evolution in 2014, and then in 2017 we added 48 volt, to it, and so it's kind of continually being refined and evolved, and many of our other specifications, the IOMS card has been an evolution from the first generation to the second, and the third generation that was released again in Q4. So this really is our opportunity to start building that same type of model, delivering to the industry a set of building blocks that we can use, which ideally helps the telecom industry accelerate adoption and remove some of that fear that they have in buying anyone's product, and that they end up that fear being business continuity. And so hopefully this addresses that, and all indication is that we're on the right path. So that's a little history lesson.
And I think too that it's not only the business continuity, but I think the developing the right plug-ins for the chassis is also there. So we need to see not only here's the chassis, there's the form factor, but also here are options to go into it to make the type application, enable the applications that they want to run.
Yeah. I also want to add too our relationship with Linux Foundation with ONF. We're working cross-pollination projects with Virtual OLT, with SIBA and Voltra, and some of the other avenues through OCP-related hardware with ONF-related software. So a lot of cross-pollination between these.
Yeah, and that's probably a good point, Jeff, is that we're really on the front end, and it does take cross organization collaboration, and we have, as a foundation, we have reached out and begun to have those discussions with ONF, with OpenStack, and with the Linux Foundation, and it's interesting because at least with ONF, they're saying that they want to start looking at the edge, and so we're saying, hey, we have an OpenEDGE appliance that you need to use as your building block, as the hardware to do that. And so our goal is to wherever possible to work with those organizations and cross promote this, cross promote the components that lead to an overall open infrastructure.
Yeah. Well, we're not the programming side of the house. My understanding was that there's potentially a pre-standard Acrano, whatever you want to call it, that runs on this platform. Actually, the first operating system that we'll use, it won't be Acrano, but it's in line with that and will become part of that software standard.
What's Acrano?
Acrano is openEDGE software release.
Okay.
It's really being driven by AT&T.
Okay, that's what I thought.
But it's going to be widely
surrounded
by AT&T is going to be a big driver.
And got it. Yeah.
The same way we used ONF as the OpenNFV releases for our OCP product, the Acrano is the target for this box. A little lighter footprint.
It's still under development.
So a couple things here. If you guys want to find out a little bit more, you can go to the Telco website, and you can get to it by the opencomputeproject.org, go to projects, and then go to Telco. And if you scroll down on the Telco page, openEDGE, there's a wiki there, and there's a mailing list. If you're not on the mailing list, please sign up. You'll get all of the updates for the calls and, recordings and anything, any presentations and anything that are being shared. They're on the mailing, get on the mailing list. And the wiki has past recordings of all of the calls. They've had probably about 8 calls.
And all the published specifications are there as well.
All the work in progress, everything's on the wiki. So please go to the wiki and, catch up if you need to as a follow-up.
And, as a question, how many people understand the difference between an OCP accepted and an OCP inspired product?
Many people understand it or don't understand?
Understand it.
Only one, huh?
Well,
2, 3?
3? Okay. So, I don't know, Bill, Archton, would y'all like to cover that for us? So, what I'd like to say, though, first is that the openEDGE chassis that we've got broken out here in the pieces, not the server, but the chassis is a OCP accepted solution. So,
It's in process.
Are you going to cover it?
Yeah, I will.
Okay.
will you
Well,
cover
no, I
the
won't
difference?
cover the difference between
Okay.
accepted and.
Yeah, you
expired,
cover the
but I'm
differences
covering
for us.
what we're submitting and at what level.
So, every single spec that is contributed to OCP is done under a contribution license agreement. And that basically means that the IP still belongs to you, but what you're doing is offering up a patent non-assert, which means that if someone uses the spec, you will not assert any patent. So the IP still belongs to you, but you're just kind of forgiving when you sign a contribution license agreement. Once the spec is in, all of our specs are available on our contribution database. You can download them, you can look at them, they're completely free of charge, you don't have to be a member. We would appreciate it if you are a member, but you can go and take a look at it. Once a spec is approved by the foundation, what happens is we need to have a product. Our specs are kind of useless without products because no one can do anything with it. So we want to make sure that if you have a spec, that there is somebody building the product out there. If you are building a product based on an OCP spec and you haven't told the foundation, please let us know. There's 2 kinds of recognitions that we offer specs, offer products. The first kind is OCP accepted, and all that means is the design files are completely open too. So you can get Gerbers, you can get schematics, you can get bombs, you can get everything about the product if you wanted to, and go build that product. OCP inspired means that only the spec is open, but the design files are closed. So in this particular case, for this server, or for this chassis, it's an OCP accepted spec. You can get everything you need to know about that spec. And all of those specs, and all of those design packages are downloadable from our contribution database. So that's the primary difference between those 2. And both of these recognitions are free. We don't charge anything for them. All we do is validate that, yes, something about the product is open. And so if you know of anyone building products, please have them come and get this kind of validation from, the certification from OCP. So long as the product is available, ready to sell, and you're offering it, these 2 logos can go on your product marketing collateral. So you can market them as well. Okay?
Bill, anything else? No? Okay. So you think we benefit from maybe an overview of the chassis design? I mean, the idea was to actually go through and do a line-by-line reading of the specification, looking for markups, but it might be good to have just an initial overview to let everyone know where we're at. Okay, so this is kind of a Nokia-centric presentation. I apologize for that. It was something I actually did for our sales conference a couple of weeks ago, last week, actually. So, we have 2 different types of form factors that we're looking at, or that we currently deploy. One is really a scalable platform meant for centralized data centers, regional data centers, something that can certainly scale from a very small deployment in the case of rack mount, but then something that's more efficient in a denser configuration like with OpenRack version 2. And so we have embraced OpenRack version 2. We have commercial products based around it. We've made several enhancements to them that are related to telco specific requirements, and we've donated those, or published those back to Open Compute. But what we're here to discuss today is really openEDGE, and openEDGE is really not about scalability, but about deployability, where we can put this. And I know Jeff had mentioned that that the radio site, and being Nokia, we are sort of radio site centric in our deployments. But to me, it's really more about space, power, thermals, the environment, and what might, and how that constitutes what would be the edge or the far edge. Right? I mean, we've had people come on the mailing list and say, well, what about the possibility of mounting this in an airplane or entertainment system? Well, yeah, that's a far edge application, that's for sure. Right? And then I've heard other people, and I think it might have been Archno that stepped out that said, what about deploying this on cruise liners? For the entertainment system, caching, CDNs on cruise liners. Well, yeah, that's definitely another far edge application, right? Where space and power and thermals may not be, the most desirable, right? So that's really what this is all built about, or built around, is not necessarily targeting this just at radio applications, but targeting this where the space, the power, and the thermals really require, and the need for some, for dense compute, really call for a form factor like this. And so that's what I kind of talk about here. This is all, open rack mount. We've actually, in the OCP Summit, we've already presented this within the Open Compute. We're actually coming out with a smaller open rack, a 36 OU open rack. And that's kind of based on our learning and experience in deploying the large 42 OU open rack version 2 chassis into a lot of the central office environments. Really led to a lot of issues as far as, door heights, weight.
Trucks. I got one right now.
Yeah.
They won't let me ship because they want it. If it's too big for less than a truckload, they want to ship one crate in a whole 18 weeks.
Putting these things in airplanes. I mean, we had one shipped over from Finland a couple of years ago. It sat in the airport in Helsinki for about 3 weeks because they couldn't find a plane to put it on. Finally, they put it on a truck, drove it down to Luxembourg, and put it on a plane to come here. I mean, so that's the kind of issues that you can deal with those large racks. But the 36 OU, basically the same as the 42U rack in height, and those can, go anywhere. And so then we get down to the openEDGE, right? So openEDGE, we have it in the aggregated edge also because, that again is about the thermals, the space, being able to fit into a 600 millimeter rack, all front maintenance oriented, no, rear access at all, meaning you can put it up within a couple of 100 millimeters of the wall and, optimize your space in a, in a fairly, dense area. And so the building blocks, we've got the chassis that we have all broken down in the back, the 1U and 2U sleds, our portfolio, we're going to add in, storage, NICs, and accelerators, PDUs, racks, and switches. We will also produce a 600 millimeter rack. I don't know what our plans are for OCP submission on that. I would expect that would probably be on the list. And
600 millimeter deep.
Yes. Yeah, 600 millimeter deep. Which is kind of the standard depth that you find out at the radio site, right? And that's why we dimension this all around that. And so the form factor itself, I don't cover this until later on, but it's really based on a baseband unit dimension, right? So, anywhere a traditional baseband unit could go, if you have an extra 3U in that rack, that can be turned into a far edge data center. Right? So that was the whole idea. And we toyed around with 5U, 7U, 2U designs, and finally we settled on 3U because it fit that baseband unit form factor. Right? And if you think about it, what does that allow a customer to do, especially as they're deploying to the far edge? A lot of these baseband units go out in enclosures, right? And so designing for the baseband unit specifications and the dimensions allow them to reuse all the enclosures as well, right? And that's, to me, that's huge. Because now you don't have to go out and work with yet another vendor to try to bring in another enclosure, qualify it, negotiate it, purchase it. You basically take the existing enclosures you're using now for your baseband units, reuse them for this. And so to me, that's a pretty powerful selling point of the dimensions of the chassis.
Okay, so Mike, on the 600 millimeter deep rack, where does the enclosure sit? Does the extra 150 sit in front or in the back of the?
It sits in front.
Okay.
Yeah, so this is 400.
So you reference it to the back and then leave 150 for cable management?
Yes.
Got it.
Yeah, because everything is front oriented.
Got it.
Right? I mean, all the power, all the cabling, everything, just like OpenRack version 2. This is kind of like the mini-me of OpenRack version 2.
So is it 600 millimeters wide?
It is standard 19-inch rack form factor wide. That would be 440 millimeters wide.
Well, that's the width of the enclosure, but the rack it goes in ends up being 600.
Oh,
it's
it's 600 deep. And what we're really dimensioning is toward the mounting rails.
Yeah.
What's the side of it.
Unlike a decathlete or other 19-inch solutions, these can go in relay racks, so you don't have that extra cabinet space with the standoffs inside of it taking up that space. It's really, we've even got some requests now for like a 2-post rail even to mount those in.
Got it.
Right, so you know what I mean? So you don't have that overhead that, like with the open rack, you got rid of the internal bracketry that it took to adapt the 19-inch 440 into, something that's mountable.
Yeah, and we are actually, part of the submission is a rail kit as well that allows this to fit into EIE 310 based, racks. Well, I didn't bring those with me because if I put those in the box, it would have been over 40 pounds, and then they would have charged me.
But see, those cabinets would be 600. With the rail kit with the square that you just click in, it'd be a standard. It'd be 600 external with a 440 aperture. But here we're just really talking about the aperture with thin rails for the size.
So the dimensions that it is for 19-inch, EIA 310, support 1U and 2U sleds. It's 2,000 watts per chassis, and we kind of divide that up with about 400 watts per U, or if it's a 2U, we'll support up to 700 watts. The power feeds we can do either 48 volt DC or 120 or 240 AC. When it's 120, you're only going to get 1,000 watts out of the power supply. When it's 220, you'll get the full 2,000 watts. Fans are part of the sled. There's no fans in the chassis itself, as you guys saw, and that's basically to allow you to use the fan technology that you need to design the sleds that will meet thermal requirements needed at the far edge. That's what we liked about the design too. You don't have fans on the chassis. It's
right.
Because some of these things are super high.
You put as much fan as you need to move the air and your heat sinks, obviously.
And if we put fans in the chassis, then you've got rear maintenance.
Yeah.
Right. So it kind of destroys the purpose of being able to put it up against the walls. If when a fan fails, you got to pull the thing out.
And I want to say that those power supplies, one on the fan power supplies, on the power supplies, the fan, one is a front to rear, and the other is a rear to front. So depending on your fan selection, you can either do front to rear or rear to front air.
Yeah, that is one of the requirements of the spec. that any sleds that are produced have to have either front to rear or rear to front airflow.
And that's because in the COs there's no uniform airflow.
Right. I mean, sometimes they'll pump the air back down in the wall, the back wall, and you need rear to front to pull, the cool air out, right? And in others it'll be, the other way.
So you got a concrete enclosure, like at the base of a tower or one of those electrical boxes. They go flush up to the side pretty much, maybe a small amount, and then they're on both sides with the aisle you walk into them. So then they want to pull the air down and in.
Got it.
Hey, Mike, a question for you. On some European CEVs, they are all fed by like a bus bar-based system. Telefonica is a good example. Have you all thought about that in some of your designs in which the power is being drawn from a bus bar? I know every operator does things differently, but especially on the depth of the individual sleds, do you see any potential modifications down the road to the chassis to meet some of those?
Yeah, I'm really, maybe that's a topic for an upcoming meeting, would be maybe to go over some of that.
Sure.
Because I'm not aware of what they do.
Especially in some of their CED vaults, they don't want any kind of power supplies or anything. It's all kind of like our open rack system. You have a DC bus bar that this thing plugs from. So we can talk about
Yeah, but ultimately, if it's like a 48 volt DC bus bar, I mean, you can always just clamp on with one of the power supplies.
Right.
Yeah.
It could be an easy modification to the chassis.
Yeah, it could be. Which, speaking of easy modifications to the chassis, the chassis itself we laid out as a 3U. We just decided to do a 2U. Right? I mean, this is, within about a week that we've decided to do that based on customer demand, customer feedback. We've got another customer that's asking about 7U. What if we wanted to do a real like dense GPU environment and use 2U sleds and have 6 GPUs in a 7U form factor? So we haven't really done anything on that yet, but I think one of the things that we need to address when we're going through the spec is, definitely the width and the depth need to be fixed, but the height, I think we're going to be able to make that somewhat variable.
Yeah, I really think that needs to be a 2U, a V2.
Oh, yeah, that would be a
V2 topic.
Specification. Yeah, that's a V2 topic.
Yeah, because the backplane isn't really, it's certainly designed for 3U. I guess you could have more, but I think we should try to come up with something a little more elegant, like that would plug together or something.
And we've discussed a couple of different things with, say, the taller one. You would definitely have to extend the power over to the other side, right?
Yeah, well, no, there's the board right
there.
Right.
Well, so at the 7U, what we might just create are 2 zones, kind of a split zone with an RMC and 2 powers in the bottom of each, and then basically have a right zone and a left zone, to accommodate. Yeah, because you're exactly right.
You're saying have 190 an L190 on this side and then a mirror on the other side.
Exactly. Yeah. And so in doing that, the pinout limitations on the backplane Ethernet and the numbering scheme, we could do something to get around that.
Yeah, I'm wondering if essentially if you look at that, it's basically a version 2 rack with the 2 zones and no center zone, where the bus bars are the connectors. So, if you're coming up, yeah, okay.
You're losing me.
Okay, so essentially, in a open rack, you would have a central bus bar, and then or you could have the 2 zones. Right. So in this case, these connectors are the bus bars, right? Rather than it being a piece of copper that you clip into, this connector is a nicer form factor rather than 2 little copper strips. But if you go to a 7U, if we may start, it may be time to think about that, because we carry more power, where these connectors and these connectors then have to be sized for the amount of power you're pushing in.
So,
Either that or this simply becomes a part of a second zone. We take this, replicate it over on this side, break that, and then lift that up to 7 years.
Yes, we're saying take this, so have this one would be 1/2, but then more connectors for 7, and then have the same thing but in a mirror for the other side.
And it's the reason we're doing
Well,
that.
it should be the same, be exactly the same. 2 of those.
It's all about compute efficiency.
2
right? I mean,
L's.
if we do two U servers in here, we basically waste a U.
Right.
Right, so you've wasted about 20% of your compute density
Well,
because it's not designed for an all 2U. When you get to 7U, then you can put 6 in there, right, and have the power distributed across the bottom, and so it's a much more efficient.
so I wonder if so this connector would be for a battery backup in this first U position. That's not been defined. So I wonder if we would have people that would want to have that, or if you would, because you would lose that with the L configuration.
I think battery backup has always been a nice idea, but has never really been seriously implemented, at least not in any of our solutions. Right? I mean, I don't know if you guys have had any different
Do we know
experience.
much about how much is deployed out there in like OpenRacks, BBU? We see it talked about a lot. Do you have any clue?
Talked about a lot, but we don't.
Well, no, I'm asking Bill. I think you probably know more of the deployment that are actually happening. I mean, because 4 or 5 years ago when they held up the drill and said we're doing.
No, but here's the
BBUs.
issue that I see with the battery backup is that I think that OpenRack deployed in Facebook is predominantly with BBU.
Okay.
So if you are a colo operator, there's no supply chain for a BBU. So you just can't get one.
Okay.
And so it's a supply chain issue. It's not a desire. Now, but I believe that when IT Renew resells a reconditioned OpenRack,
Right.
I think they have BBUs in it. So we're going to see a lot more of those out there, throughout the world.
As they cycle through.
Yeah, right. And so I think there's a pent up demand for BBUs that just aren't fulfilled today.
Right.
Okay. Mike, another quick question for you. When you look at version 2 for the 7U version, is there any thoughts on instead of like a passive backplane, maybe a PCI, maybe have some internal switching? As you're getting bigger, right, there may be some needs for. Am I stepping ahead a little bit too much?
Very good comment. One of our design guidelines is no integrated user plane switch. You guys ever do anything with ATCA? ATCA?
Oh yeah.
Yeah, ATCA. Okay.
I never heard it called ATCA, but yeah, we are.
Okay, I went through 3 generations of ATCA, and the first generation had a 1 gigabit backplane to it, right? And I was told, this is solid. Don't worry. When the 10 gig spec comes out, this is golden. It's going to work just fine with it, right? Well, when the 10 gig spec came out, they said, well, no, the dielectric properties of the backplane isn't quite appropriate for this, so 10 gig isn't going to work. Here, you'll need to buy a new chassis. But don't worry. When the 40 gig spec comes out, this backplane is going to be solid. Right? What happened when the 40 gig came out? Same song and dance. We ended up, about every 2 years, 2.5 years, we ended up having to replace the chassis.
Well, and this is exactly what happened with blades.
Yeah.
But I think we have to look at the blade industry and say, why did blades fail miserably?
Right.
Because there was 14 different versions of them out there by every OEM, this promise of, having multi-generational, enclosures was a false promise.
Yeah. So what do you want to do with the PCIe?
Well,
I mean,
that's exactly
is it
why I
I/O
have to
that you
recreate
wanna
these
do?
designs every 2 years.
Or is
That's
it
the
just
reason
power?
Well, and so,
Is it I/O that you want to do through the PCIe, or is it just I/O?
No, it was future-proofing the
just
product.
power.
It's kind of future-proofing the product, making sure that the backplane doesn't go through constant changes. Now it's a passive, then it's going to be PCI, then it's going to be on fibers, then it's going to be.
that's why,
And we see that
everything is.
That's why we
front
see
cable
everything coming off the front, because then, you're always upgrading the front connections, and all you're doing is the power on the rear.
Plus, you're dealing with cables,
You
which
know.
is inherently faster.
This
Right.
is all we've got on the backplane. Right, we got 12-volt power that runs each and every sled. We've got in the RMC, we've got a small layer 2 switch, so gigabit Ethernet goes out to each and every sled. I mean, when do we think that the BMCs will move beyond gigabit Ethernet needs? I don't see that. Right? And then on top of that, there's just a
promoting it because I don't want changes constantly, right? I would prefer this than maybe a
Well,
next step
that's
to
what I'm
PCI.
saying. Mike just went through our ACA experience, which is it never gained acceptance. It was always the next, and that's kind of why we're going now. Well, why don't we go with the front and not worry about trying to keep up with the PCIe? And now with the change, from the version and the faster one, it's like, okay, your blades are done. They'll never upgrade them, right? Whoever's got blades or ACA chassis are stuck now.
The only other thing we put on here was just the
Hopefully they're in the
management
life.
bus, the SM bus, right, which is used for the fans and power, or the power supplies. I mean, we don't see the SM bus changing anytime in the near future. And then just for the hell of it, we also ran them out to the BMCs. We don't have any plans on that at this point, but it's nice to know that if we might need a backdoor into the sleds to try to recover them, that we'll be able to do that from the RMC.
Perfect.
And what I really like too is to get some. We need some adopters to weigh in. If the adopters want PCIe, let's put it on there. If they don't, let's not worry about it. They want
So we
PBU,
live that
let's
dream.
keep it on there. If they don't, get rid of it.
Then you got retimers you have to deal
No.
with. I mean, there's
You've
a
got
lot.
Gen 3, you've got Gen 4 upcoming, Gen 5, Gen 6.
Right.
So yeah, we've lived that dream, and we prefer this.
So back to the 7U. At some point, there's a power limitation. What's that? Where's that point today?
Oh, as far as weight goes?
No,
Or-
total power consumption.
Oh, well, I don't know if something like a 7U would necessarily go at a far edge site.
Okay.
Go at a, I see applications of that maybe being edge gaming, where you have, a gaming service, say, I know that there are multiple companies out there that are doing it right now, where they want to put GPUs at the edge, maybe not necessarily at the far edge, but at the edge, to be able to, to drive some of these gaming services.
Yeah. Or they call it virtual CPEs, kind of things. So you're gonna have to get a new gaming console. Your virtual CPE runs at the edge, and then simulates the latest, game server, and you just have a connection at your house where you play it. Rather, if it has a service, you get your Nintendo.
Yeah.
Or your
Right now, most of
Xbox.
the online gaming is all, the only thing that really transmits between the console and the centralized servers or telemetry data, right? Just control data, right? What they're actually talking about doing is decreasing the cost of their consoles by locating GPUs at the edge, making those a shared resource, really virtualizing the GPUs, and then having that as a shared resource. And now you can play it on your TV, your laptop, your phone, whatever, and it will render it for you instead of putting all that money into the GPU.
And the parents like it because they don't have to buy the new Xbox for the kids because they never sit there being cold.
Yeah. I
Where
heard
here they
something
can get it
about
on demand.
Microsoft, they lose $400 on every Xbox One they sell. You know, they're trying to figure out a better way to do that. Okay. So anything else on the chassis?
So, what kind of power, what limitations are you talking about, Bill? Like the power supplies coming in? Or are you talking about the amount of power that can go through the connectors?
All I'm thinking about
To
is,
get to the
you know, is
servers.
that power densities. So in a CO, you know, the power densities are pretty low. It's, at the edge, is there any limitations on, you know, when you put it in a cabinet, is there a limitation?
Well, and that's the thing, right? I mean, we've got a 3U, we've got a
You
2U
got
upcoming.
10,000 watts in an enclosure.
Yeah, well, they're pushing, what, 12 and a half per 20, 25 kW of open rack in the COs.
Well, I don't know what they're deploying.
That's what I'm saying.
Okay.
We got some of
25
those.
kW.
Is
Yeah,
that applicable to
power
US only, or is that applicable to, you know, emerging geos? Because the power is so critical in those geos that, you know, I'm not
But
sure.
these are in the large data centers that are equivalent to their, you know, to cloud data centers, where, you know, the main data centers, there's like 4 or 5 of these per carrier in the country.
There are a lot of customers out there that have, you know, data centers that can't accept any more than about 4.5K per rack.
So is that a central office number?
The, you know, you mean the 2,000?
When you say 4.5K,
4.5K, that's more of a central office.
Okay.
Right? And it's usually cooling, not,
Yeah.
you know, more than power. Right? And so there are like rear door heat exchangers, hot aisle containment,
Right.
those sort of things can be deployed.
right. So
create a denser
back to
environment.
that
Yeah.
4.5K in a central office, which this could end up in like a 2-rail rack or something. So why would you ever need anything that's 7U? Because now your 7U at 700 watts a slot is going to be
It would only be for
13 times 700.
It would only be for an accelerated, you know, a highly focused accelerated case, right? Edge gaming, edge video analytics, you know, edge machine learning, AI, that sort of thing.
Okay, so let's slow down. So machine learning, you got a neural network. Those are probably going to have between, you know, nominally 4 GPUs, maybe 8 or 16. You know, programmed in a, you know, series, right? Serially. That's not an edge type of.
Right.
Not today. I mean, I know for a fact that we're looking at using GPUs for optimizing massive MIMO antennas.
But that's different than deep neural network.
No, but I'm saying
Machine
that's
learning.
an AI-based.
Yeah, but that's one processor. I agree with
no,
you.
it's one
but that's
network. It's a smaller network that's
so you have
required for the
one
massive
service
MIMO.
processor and you have one.
It depends on the
accelerator.
number of antennas you have and what the density of your.
Yeah, but it's not like. But it's not like running Siri or some kind of facial recognition.
No.
You know, that requires a big
that's
installation.
That doesn't require. That's 20 watts of hardware accelerator.
Wouldn't it be beneficial to have multiple 1Us and 2Us to increase if you want to increase with GPUs? That you want to grow
that's what
versus
we're
the
saying.
7U.
Yeah, that's what.
Well, that's where I'm at.
That's what we're saying.
That type
of the chat. We've got some, and that we're now starting to develop a 2U for some folks, but then we're also having other customers that want 7. And ours was like, well, let's split the difference and make 3 when we did our work,
Okay, great.
because then we could make more.
I mean, right now, we can deploy 5 1U servers, right? Or we can deploy 2 2Us and a 1U, right? Or we can deploy a 2U and 3 1U, right? So we've got the, we've got the option where you were talking about having a mix. We could do that just fine in 3U, right? This was just a specific customer case.
Right.
unless they decide they want a battery backup. If they want a battery backup, then we're golden again, right? Otherwise, it's just that it's a 20% hit on your compute density efficiency by having that there. But if we had a 7U version, that would optimally fit 6 2U circuits, like 3 and 3.
We are seeing some, like from EMO for 5G, as they're transitioning from 4G to 5G radios, they are requesting more GPUs at that tower. Now, whether you need 8 and or 12, or we're saying 2 to 4 is kind of nice.
Okay, agreed. What's the ratio of service processor to accelerator? And I believe that ratio is 2 to 1, right? One accelerator, 2 processors, 1 to 1 or 2 to 2, or 1 to 2, right? It's not in neural networks, it's minimum of that and more like 1 to 8. The bigger number of GPUs that you that interconnect is an interconnect that's GPU to GPU. So there's back to looping around, no need to do that. You just need one cache coherent connection to one of those.
That's where we kind of need AT&T and Verizon.
Well, yeah, and they'll drive those requirements. And like I said, the whole discussion around 7U or 6U or 9U, whatever it may be, I think just as we lay out the 2U spec, we have to keep in mind that while the width and the depth will remain constant, there is an opportunity to vary the height.
Yeah. Okay.
And it'll totally be driven by who wants to pay for it and who wants to buy it. If AT&T came out tomorrow and they said we want a 7U chassis, we'd make them a 7U chassis.
And the sleds will always be interchangeable between the 3U to 4U, 5U to 7U.
Oh yeah, absolutely. And as a matter of fact, one thing I didn't mention, and unfortunately I don't have on this particular chassis, is that there's actually a hot swappable or toolless mounting bracket between these two that you can just remove and turn two 1U slots into a 2U slot, right? So it's a toolless design for that. And you leave it on the inside. I think you see the little mounting pins.
Yeah, we don't have the adapter shells in this particular chassis.
I was in Finland 3 weeks ago. I saw one of these sitting in a lab. I begged for them to send it to me so I'd have something to play show and tell with. And so beggars can't be choosers. Okay, so a little on the sled, 1U sled. We have it is a single socket design. With the shorter form factor, we simply did not have the room to put 2 sockets in there and have room for any sort of peripherals at all. It is based on Intel Xeon scalable processors, but we would certainly like to see other options available to us. Thanks to industry. There may be an opportunity for an ARM-based platform as well. And then as far as other 1U and 2U options, I mean, there's all sorts of, our Western Digital and Seagate people here. We don't have anything on storage arrays. There may be an opportunity while SSDs are fairly dense in nature, maybe for some, real-time video surveillance or edge CDN types of applications. Maybe a denser storage array would be something that could become in demand here in the near future. Optical cards, small switches, create a completely integrated solution. I mean, it'd be great to be able to send this out to a far edge, a 3U solution with a toreless design, or with a site router that's integrated.
Sounds good on that side.
And then the 2U version, which is really largely the same as the 1U, with at least the motherboard is. We have some larger fans. We can put a little more storage in here, but most of all, we can accommodate a full height, full length card. and this goes back to the whole GPU discussion, and
You're
double width.
Sticking with the 2.5 inch drives only, that's it?
Yeah.
For this,
So we decided to stick with 2.5 inch only. For one, it's it's about the limited space we have in a half U server. Right? We do follow up. You notice that so even in the 1U, I don't have it broken out, but we've got the two SSDs, which can either be NVMe or SATA. But then we also have, where are they? Oh, two M.2 slots on them as well.
no, I was most interested in EDFF form factors, basically,
Those.
because those will actually give you more density
Yes,
than the 2.5 inch
What
drives.
form factor?
EDFF, the ruler,
Ruler. Or for us, it would have to be the half ruler.
long or smaller ones.
Yeah, we don't have enough depth for the long ruler.
The longer ones I understand
It would be
that,
the half ruler.
but the shorter one is weird.
Yeah. No, that would certainly give you more density.
Because what we see in CDNs that the storage is becoming very critical, especially when they have to have certain capacity to maintain that aspect. So
Yeah.
And that's non-volatile storage?
Yeah.
Always?
most of the cases not.
Is that because of
Well, if you're doing for latency and performance, it's non-volatile, but there is also always a library in the back that can be a rotation medium.
Yeah, we've always used two small form factors for boot, and then NVMe's for the data on the CD.
Ideally, I think so. This is a great design, but I think so would be for this form factor I see mostly NVMe, but there is a possibility that a disaggregated storage can be linked to this thing to provide a much bigger catalog of libraries.
Very good point, and it's something that we looked at, but the question is, were the rulers ready 9 months ago when we did this design?
Yeah.
And did you have a proper locking mechanism in place for the rulers 9 months ago? No, it wasn't.
No, I understand that. I mean, as we move forward, that's what we would want to explore.
So let's draw a distinction though, okay? So that we have, the OCP accepted is all of this and that sheet metal. The server is just inspired, and the intention of it, we also have blank server trays so that others can develop their own servers. So the intention here is not to come up with yet another server for OCP, but rather a form factor for the chassis, and then have other vendors develop cards, plug-ins, whether they're servers or storage or network cards that would meet that form factor. So we're not trying to push this as an accepted solution, but only an inspired, because this is what we're offering for the applications that we're using it for.
Right.
So, but we think it has lots of different applications. Just
Yeah, I mean the chassis and the sled itself, the
Right.
sled metal, that's
right, all that's accepted.
OCP accepted.
So do we have sleds which are VOD versus live video versus GPU? I mean, are we categorizing them as part of our specs, or?
No, but see, hold on. So what Craig was trying to articulate is that the whole idea is we get, align around some common form factors that create interchangeability, right? And so, and allow innovation.
This is accepted.
Allow innovation to occur, with those different configurations. So, if you serve a market, or you have expertise in AI technology, you may say, hey, I want to be the AI, or GPU provider. I can just take this design, I can go grab the CAD files, I can build an enclosure and drop my motherboard in, and I can have a deep learning machine, or I can have a VR machine, right? Or I can have something that does, 5G signal conditioning.
This is our playing pen, basically, so we just.
Well, yeah, but think of that's a building block,
Building
and
block,
so
and
all
then-
the design
yeah.
files are available for this and the enclosure, and you create, and there will be companies that will, open source the baseboard, right? In fact, it's to their advantage to do that, right? So it would make total sense to, make total sense for, Intel or AMD or ARM or somebody to have a generic baseboard that people could then, innovate on top of, right? And release all the design files that fit in this, right? And then you get more innovation built on top of it, because a company can say, hey, I'll just swizzle the front end, I'll shift things around, and 90% of the design I can duplicate. Right? I don't have to redo.
You can come up with a reference design. Your customer would implement that, change things around to fit their particular application. They're off, they have the rest of the infrastructure that's already been vetted with customers, essentially.
What we don't want to do is have, 2 or 3 other designs out there, because then we end up like ATCA, or not, sorry, not ATC, but we end up like, Blades, right? Or we end up, like, it just stalls the industry.
HP has a blade, IBM has a blade.
Yeah, I mean, but it stalls the industry. Nobody wins in that.
Just another quick question. One of the things that we also hear is the telcos are very cost optimized. So are we making sure that all the ingredients that we're putting up there we can basically optimizing for as lower cost as possible?
I mean, I think if you take a look at the simple chassis design, the sheet metal, it's the vanity free.
So carriers are absolutely cost concerned. Their cost is not in BOM cost. Okay, that's the farthest. That's so low on their cost scale in BOM cost.
Well, the other thing is also OCP is not really looking for pricing. We don't have pricing on our website. We're just providing the platform for collaboration. So, anybody that wants to go build this product on a very cost-effective scale can. All we're going to do is provide the platform to collaborate, right? We don't provide pricing.
Yeah, and like actually, if you look at the BOM, I mean, these are standard, they're standard SKUs, so it's going to be quantity. The board file, you have all the design files to build the board files. It's not like you have any engineering costs associated with that. So from that standpoint, it's good. From a carrier standpoint, while it's open source, to carrier, open source is not that they're going to go build it like you would open source software, because you don't have the tool chain necessary to build a board. However, open source in their mind at this level comes from being able to source it from multiple vendors.
That's what they care about.
Yeah, and so by us,
it's all about business continuity.
yeah, here's your board, here's your schematic for the board, here's the Gerber file, AT&T, if whoever, you can go have somebody else make it.
They will never buy the ingredients and put it together.
Right.
They will always buy it.
They talk about it.
Right.
They talk about it.
They talk about it all the time.
And during the development phase, they will pick and choose the ingredients that they want to have in the box. But at the end of the day, they're going to write one purchase order.
Yeah, they want to be Facebook. They want to be Amazon.
Facebook doesn't do that. They buy a whole rack at a time.
Well, no, I just mean it's their own design. They go to the ODMs themselves. They pricing. They basically cut out the middleman.
What's the Intel version 3 motherboard, and it's it's the same kind of thing.
Mike, are you seeing any pull-in for Xeon Ds? I know everything is, gold, platinum, whatever. Do you see any?
I think maybe with Ice Lake there might be an opportunity for that. It seems like the power and density of the Ice
and
Lake,
the integration.
yeah, may get to the point where it's going to be a good match for it. And that would certainly be, to your point, a step toward reduced pricing. you know, and a simplified design.
Got it. Thank you.
I don't know if I should have said isolate or not.
And having Intel kind of put their fingers in the ears, NVLink, any needed for NVIDIA NVLink?
Internally or externally?
Well, so Jeff, how would that,
On
what
the board
implications?
itself, for AI and these
Okay,
things.
so, but who cares?
Yeah, build one.
Build one.
Well,
Here you go.
so that's
How many
where
can you
that's
fit
where
on
the
there?
ecosystem comes into play. We would love to build one. We're building them now for some of our products, but where's AT&T and Verizon, and that's where we need some input for Nokia, because Nokia is a big customer of ours. We want to build things, not just to build them. We want to build things people are going to buy and implement and sell and all that. That's
Part of OCP is also seeding the market as well, you know, creating that demand through an innovative design.
So we do have one of our keynotes is with AT&T, the call to action to get
Right.
AT&T and OEM co-keynote is a call to action to get on board on open infrastructure.
And, obviously, we have regular conversations with telcos around the world, not just the ones that we think of. Here they're participating in OCP, and we continue to, have, ask, would you join the calls? Would you help drive this product? You like it, you say it's good, you got some things that you want different. Well, this is a product that you can influence product. Join the call, join the OCP, participate.
I have 100 customer meetings a year. I cover both North America and South America. And so I'm in a unique position that I see all sorts of different demands, different limitations. I even had one customer in Canada say, we want the absolute densest compute solution you have. We don't have any limitations on power. We don't have any limitations on cooling. We just want the densest rack you can provide. Wow. Never heard that one. Okay.
I don't think that's an immediate issue with how do you support NVLink or CAPI or because that's going to end up being embedded in years, but I'd like to give you a hard time.
Yeah.
As you know. I think, when we start talking about what do we do in the future, there's an emerging project that we'll announce on the Open Accelerator module that'll support, multiple accelerator models and interconnect, but there's nothing that prevents those modules from fitting in a,
form factor like this.
that form factor. So,
Okay, so move on to the RMC.
yeah.
Talk a little bit about that. Okay, the RMC, the rack management controller. Basically, it has a small ASP microcontroller on it that monitors the power supply, and then we have an unmanaged layer 2 switch that interconnects with the server blades. The up to 5 server blades in the 3U chassis. There is a USB console that goes directly into the microcontroller, and at the same time we've got an RJ45 gigabit and then 2 SFP plus 10 gigabit. Now the 1 gigabit RJ45 is great for the craft that actually goes out to the site and needs to plug in. He can plug in and get access to all of the all the BMCs, all the microcontrollers. The 10 gigabit is basically envisioned to be part of the management platform. The out-of-band hardware management. Not necessarily in a redundant manner, even though you see 2 of them there, but to be able to daisy chain multiple chassis together. Right? Because the cabling's at a premium, right? I mean, we've already taken really 6 cables down to 1 by the taking, multiple chassis worth of cables down to really one uplink port by being able to daisy chain those together. Hey, by the way, we had somebody just join. Hello. Hi. My name is Rob, and I'm using Edge. I'm from Cloudflare. Okay, welcome.
So that it's basically just, it doesn't really talk to the BMC, or just using it just for a switch function?
Yes. Yeah.
Does it pass?
The BMC certainly configures up the switch initially, but it's really just an unmanaged layer 2 switch.
So your server board still has its own BMC, just like any other.
Yeah.
But you don't have to plug an RJ45 into 5 and have 5 cables going to some management switch. They can talk through the RMC.
I plug into the RJ45. I have access to everything in that chassis.
And if you daisy chain them with a 10 gig, you then only have maybe one connection into SMT4. Because gigabit management switches are getting kind of hard to come by too, right?
So in this case, what would be the two 10 gig ports connect to?
Well, so let's say on one chassis, let's see, one 10 gig might go up to the the site router, or to the top rack switch.
Site management switch.
Yeah. The other 10 gig can either be just left empty, or you could take that down to the next chassis. Let's say you had 4 or 5 chassis. You could actually daisy chain those all together, and then just have one port, for your maintenance. I mean, that's quite a savings if you think about it, especially where ports are at a premium at the edge.
So now we have
So you're not forcing somebody to have a 1 gig switch.
Right, with
in their
BMCs
enclosure
going to every one of them.
You can just have, you get 5 connections into that switch, you get 1 10 gig uplink.
And daisy chain all of those chassis to one management port, 10 gig SFP somewhere, to a switch you designated as your management switch.
For your BMCs, they're all ASTs, they're all...
Yeah, the standard server BMC. It operates just like any, open compute server you would expect with a direct connecting. You don't even know whether they'll have their own IP address, and but it's not meant to be a rack controller or a blade controller, in like a blade system that's got some kind of, I'll give you a console and I'll give you a connection and a KVM. All that behavior still comes from the BMC on board.
It just monitors the power supply, and it's a pass through to the other BMC.
But if you have a failure on that one, then you basically have to reconnect the daisy chain and back to the top of the rack.
Right. I mean, the
if
maintenance
that's your
networks have
architecture,
never been redundant, right? I mean, every server I've ever seen, you only have a single BMC connection to, right? So the fact that you don't need the RMC, I could go extract the RMC and the servers would still just run fine. We didn't think that was something we needed to invest the extra cost to enable redundancy.
It's trying to keep it as simple as possible. So, some blade systems or access systems have dual management and then have their own traces. So if one fails, you can go to the other, but you then don't have the capability of having the onboard BMC getting your logs, all that information from each individual server the way you do here. So it's just a standard server BMC arrangement on all of them.
I forgot about those dual systems.
So
managers on ATC.
Yeah.
I'm just trying to catch up. So I was saying that it's trying to simplify the regular BMC, so compare all the regular active microwave.
Yeah, all of that still works. Just to back up ever so slightly, what the RMC actually back up. What the RMC does is it gives you basically pass-through access to all the servers, right? So you do get connections to the rack management controller, BMC that basically just controls the the network, reducing the number of cables, representing, the entire chassis or multiple chassis really with a single network cable.
So, you would also replace regular NICs that you would have?
Well, this would just be for, maintenance, just for IPMI, Redfish, S&P.
Out of band.
Yeah.
You still have OCP mezzanine and a PCIe slot that you could put, where your I/O would be for the server.
More direct reading on basically how usually most of the whole chassis how
Right. I mean, most rack mount servers nowadays have the baseboard management controllers. This is the same concept. It's just instead of having an individual RJ45 for each and every one of those, it's combined in the backplane and presented by the RMC.
So Mike, is there, on the BMC or RMC, don't we need to have the API defined?
Yeah. Very good. You're reading my mind.
Well,
So,
technically you don't if you just treat it as a pass-through to the switch, and you address each node. But I don't think you do that.
no, and I think this is an opportunity for us to get this design involved with the OpenBMC project and come out with a common software solution, associated
For
with
the
that.
RMC
What?
currently.
Yeah.
We're working on the OpenBMC for
I think there's two
our
steps.
BMC.
I think there's two steps to this. One is, the first step is, because this is a AMI licensed code, I think the first step is how do we document the north and southbound API so that any company can
The Redfish.
design well, first off, you can design a board to slide in there and it's going to work, right? But if is there anything you have to do in the board level BMC to work with that RMC? It's probably very minimal, but at least you'd want to know that.
I mean, all you have to do is just
Gotta get
follow
power
the pin-out connectors. Just the pin-out connectors.
Right.
Connect the BMC to 1 gigabit Ethernet, and you have access to your BMC.
It's the power. It's the control of the power supplies that be on the RMC control.
So if you think about it like this.
Oops. It's all right. We could have an OpenBMC implementation so we can then spec our southbound interface or northbound, whichever way we're talking. Both, I guess. But one would talk to the power supplies, and the other would talk, to the Ethernet to go outbound, upward. Okay. Then you have on the servers themselves another BMC.
Right.
That would be the OpenBMC. That's going to be a little more difficult to get all the features that we have currently.
That's what
from the AMI.
That's
on the server though.
Right, but that's the first. So the first step is, how does a company assure that when they design a server sled, that they have all the right features? So the physical link is easy.
Right.
Okay. It's the API support in their BMC. I think
they have Ethernet.
So on the RMC, you could go to AMI initially and say, hey, would you make these? If you don't like the RMC, go to AMI and say, can you change this for my enclosure?
Yeah.
So the enclosure I want to ship.
Okay. Yeah. Somebody else's server, you're saying.
Yeah.
Yeah. Okay. Change their code. So how do you specify the northbound interface to the BMC today, other than an IPMI keyboard connection or Redfish or a vendor-specific API?
That's how we do it today.
Right. So that's how you would continue. That's how this one is done, and you would continue to do that,
And then what I was talking about though was OpenBMC running on this versus an AMI or other
OpenRMC,
code. Yes.
running on it,
No, OpenBMC
running on where?
on this server and
Okay.
on the RMC.
Okay,
So both of them, there's the AST 2500 on the server. There's an AST 2500 on the RMC. We're going to be able to open the RMC up, but it won't have any firmware, right? Because it's licensed firmware.
Yes,
but we
right.
can get the hardware. So we
Yeah.
need to have the firmware group and the OpenBMC group write code for the 2500 on the RMC to communicate the information from the power supply.
so I think there's a two-step process. The first
Yeah.
step is, don't worry about open source.
Yeah.
Just forget the open source path for a minute.
Yeah.
And simply say, what is the documentation we have to have for both the node and the appliance, right, the enclosure. And then secondly, then how do you migrate to an open source base, right? That's the second step. But I think the first step to remove the barrier to adoption is at least give people a path. And that path can be, go to AMI, have them make the changes to you and drop a binary and reflash.
Well, so we can provide the binary. It's just not something that we're able to give, and it can't be OCP accepted. But we can do the hardware now.
Well, you could provide the binary of the in the enclosure.
Well, I'm not sure that we would provide the binary for either.
Okay, but
I mean, the binary obviously comes with the server. You buy the server from us, you get it.
well, the
And it's
enclosure,
documented in the accepted
the
stat.
enclosure.
I mean, the inspired
So,
stat.
so, let's say, my Acme SI company wants to resell that enclosure, okay? So I can go to AMI and I can say, I'd like to get a binary for this RMC, right? And I could get it licensed. I could install that binary. That's an acceptable path to enable.
Well, it would be your motherboard with AMI and however you develop your firmware, and they would give you firmware, and you would make that available to your customer as part of your server board.
Yeah. Right.
Okay.
But at some point you want to say, hey, I at least have some definitions around what the northbound API from the Sled is and what the southbound is from the RMC, just so that people can independently design these sleds. And have them plug and play together.
Okay.
Right.
Well, so I guess maybe we should get maybe we should get some of our other engineers.
So you mean,
involved
how do
on
you,
that.
in other words, when it comes into your RMC, what's the SM bus address? What's the, credentials? How do they pass credentials and things that are pretty specific to that implementation? Little things like that has to be documented.
Yeah.
And Craig, what you're doing on the openEDGE, are you
Trying
trying to stay in alignment with airframe as well?
Or what do you mean? From a firmware standpoint?
Yeah.
Yeah, so all of our servers run the same firmware or the same BMC code, and we're moving that development to OpenBMC so soon, whenever feature parity can be achieved.
Which
So,
on the server node may be a ways away.
Well, I don't know. I mean, we've got, it could be. I mean, it's just, I guess it would depend.
It could be a year or two.
We've got the decathletes, we've got the
I'm just saying, at the server node, it
open
could
rack
be.
servers, we've got these servers. I think it's probably a matter of customer request. And, if we had a customer that said, we would like to have OpenBMC on it, this would be the first thing that would go. It could be the
cat leaks, because they sell pretty well as
Yeah.
well.
Well, that's interesting. I was gonna ask Jeff this, he stepped up, is that, I don't think telecom customers would ask for OpenBMC.
Depends, I mean, I think it's the same kind of,
It's hard because their buying habits are
Right.
going to OEMs and buying the platforms.
yeah.
Exactly.
And that they're
No.
not building the
Okay,
platforms
yeah,
themselves.
but a lot of times they like to have, code in escrow,
Right,
right?
right.
So they may, hey, it's okay, this firmware you're running, but we've gotta have this firmware, and the NSA requirement in North
Right.
America requires us to put code in escrow anyway, because then we're finished.
So, but that was my point with
But that's
with
just,
using AST, is that in effect you have code in escrow when you use
Right.
AST. So AST is an enabling path for this.
well, no, I mean, you could run
I'm sorry, AMI.
AMI, yeah,
I'm
you could
sorry,
run
AMI.
multiple codes on
Yeah,
AST,
yeah.
right.
AMI is
Including OpenBMC. It's just not as mature as a developed product, obviously. And especially in terms of Redfish. I mean, OpenBMC's IPMIs,
I don't know, Alan, how often do you
You can
see
do some
requests
things.
for open source
I don't see
firmware?
as much from the telecom side. You have to be able to answer that question.
No, I don't think anybody quite realizes yet. It's the same way, it's gonna be the same way with your OS stuff. Oh, I didn't realize that's just Unix under there?
Yeah.
Oh, well, some real-time Unix, it's whatever. Well, could you run CentOS? Could you run Red Hat? Okay, could you run Ubuntu? Yeah, okay, come on, And as soon as they, understand, because they're participating in OCP, they're watching OpenBMC, they see Facebook saying, we have FBOSS and it talks to our BMCs and this is the way we bring things up, and they want that user experience. And I think they don't understand what OpenBMC means, but they think it means it has an operating environment for their OSS system. That can mean they can provision servers the way they want by controlling that software the same way they control the software that's running the service.
So Mike, what's does Nokia have a plan in terms of API definitions, or?
Well, I mean, our API definitions are based on Redfish. There's nothing proprietary about what we're offering here.
Right.
So it's all based on, and I can't remember what release of Redfish, but we're following fairly closely. And it is an AMI image, so as soon as we can get AMI to integrate the latest version of Redfish, that's what we're
2017-2 or whatever it is. I think we're on 2016.
So on the,
I know we've got a pretty quick cadence this year to try to get caught up.
Well, everybody does, right? Because the 2016 only lets you read, 2017 lets you start doing that operation.
Is that included in the spec, the revision level of the?
No.
Okay.
No, not at this point. But that's a moving target.
It will.
Yeah, I know, but I'm just saying, what do we need? What else do we need to document that level of compatibility? In other words, think about an ODM that wants to build a board to go in here, or Sled to go in here. What would they need to build a Sled without calling Nokia?
I'm kind of wondering, is this so much a project that would come under openEDGE, or is this something that we might want to have started in OpenBMC to basically create a common API, not just around this one RMC, but around everything?
I can't speak to what's going to happen in OpenBMC.
Yeah, well, whatever our open, our open.
It's not a OCP project.
Our open RMC should be able to do some of this, though. This would be a kind of a good task for those guys, I think. I didn't get to attend last week.
API that's extended beyond, just openEDGE.
Nope, it isn't.
Oh, yeah.
Nope.
Whatever.
That's news to me too. I didn't
Get out of your way.
IBM chose to have that chartered under LM. Yeah, but they don't.
Well, they say it's both. I mean, they still prominently say it's an OCP, not project, but whatever.
They're trying to tie it to hardware.
Yeah, but they keep trying to have one foot in OCP and one foot in Linux Foundation as hard as they can. If you go read all
because we're the only one
the
that gives them a
documentation
community.
over it. You know.
Without OCP, there's no community.
Yeah.
Right.
Right.
Bill, to answer your question, we haven't seen any hard requirements for OpenBMC.
For open source.
A lot of times they'll ask us, we'll support it, and we're like, yes.
Okay.
We'll
So the
support
notion of using AMI as a firmware developer is not a roadblock.
That's right.
Okay. That's what I'm thinking. I mean, someday it'd be nice, but it's not a.
Well, unfortunately for us, we have to support them all.
Yeah, but I think
back what you just said
here
though
is like the wedge. Wedge uses OpenBMC, so he uses only an OpenBMC. The servers on the wedge run OpenBMC, only gets it started. And I think that experience of saying, hey, we have our DevOps experience on our switches, load those. And from a telco standpoint, I hear them saying, we want to be able to operate not only our network, but our compute and everything else, our OLTs, everything with one common DevOps experience. Yeah. And so while they're not speccing it out in their RFPs or RFIs yet, that's the stuff that I'm hearing from telcos in regards to OpenBMC. But a lot of times though, then it turns into redfish with those guys because it's kind of like, redfish is the everything now before where it was IPMI. But
the problem is they'd like to have a single consistent interface across the
yes.
stuff. They're not willing to support it. They're still going to go out to a supplier or ISVs to go and provide that aspect because they don't have resources. They want somebody to solve it for them.
Of course.
But
of course. Of course, we solve it for them a bunch of times. They come to us and say, we want you to solve this.
There's times where they have been asking anything you tell them, they'll say yes, they want it. But when you go and put it in front of them, what it takes, sometimes it doesn't work that way. So if you solve it for a broader.
Okay. I'm sorry. I'm kind of swapping hats here, and I guess maybe I should say which hat I'm wearing. As the OCP Telco co-lead, I hear telcos say they would like to control it, and they talk about OpenBMC. At Nokia, I don't hear anything about it. They talk about redfish, and they think that if they have redfish, they have the consistent interface to have their management OSS be able to talk to the hardware and have that DevOps moment that they want.
So we have
But, I'm sorry. I'll try to do better of which.
Well, I'm mostly talking
one
from
time
your
we got
other hat,
there's
from your
other
Nokia
lines.
hat kind of stuff. That's what we're dealing with at this time.
Well,
Right.
no. So today we're not dealing with the Nokia hat at all. We're dealing with Open Compute.
Understand that.
And a platform for us to have as an OCP.
So we have our hardware management group
R2.
under the guidance of John Leong from Intel, who's been diligent on this, has created a set of redfish profiles that are mandated that are not yet mandated, but may well be someday.
We've
hopefully.
accepted them all. Each group
So
accepted our profile.
Right. So the profile, there's two profiles that have been accepted: a baseline and a server. And we could create, for the rack management, we could create another profile that states what are the properties, the redfish properties that are required for a rack management controller. We could do that, and that would be sufficient to assure interoperability and plug and play. That hasn't been done, but Mike, if we created that profile, that would work.
And
today we have on the server level, we only have one product on our website that actually has been tested and complies with the server profile.
Oh, I need to do that.
Yeah.
Our new telco optimized
Does it-
open rack server that was just,
Well, it probably does, but we've only had one
We need to
company
go- we
that
need to
actually
test it.
downloaded
yeah, we need to download the
the
profile.
self-test and ran it.
Yeah. We'll may exceed it, but yeah.
By the way, once we get more than one, we'll probably end up trying to advertise that on the,
Right.
on the marketplace. But so I think that would be a reasonable approach, not get into source code or license, but just say, hey, at the enclosure level, this base code from AMI meets this profile and has those features. That would also allow us to get into any extensions beyond Redfish.
Mhm.
So if you wanted some CLI commands or something, we could actually include that in there too.
It'll likely be a reduced profile from a regular server profile because we're not dealing with nearly as much on the RMC. I mean, a little different for, well, it's an unmanaged switch, so I mean, there's no real APIs
Right.
there. It's really just managing the power supply.
Right.
That's all they do.
Well,
And a little bit for board insertion and extraction, so
Right.
there's a little bit of enhancement on top.
yeah, Bill brought up the SMB addressing.
Yeah.
So
We
there
actually-
may be a little bit of that for
Right.
but we have to check it.
Yeah, we haven't implemented SMB yet.
Well, you have to know this SMBus addresses if you design a board.
Right.
Yeah, but I think what he's saying is we're not using it, so basically when the Ethernet switch
Oh, I see.
sees the link from, it brings up link to the Ethernet over other traces, and that's just not even used yet.
So like inside the power supply, do you pick up current, voltage?
Oh, well, I'm
They
sorry,
want
I'm
PM
talking
bus?
about to the BMC, the BMC to Ethernet switch, not the AST to power, right? Because it's running its own code that controls the power monitoring and usage and all that junk. Right?
Right. I mean, here's from the RMC, the SM bus goes to the PSUs themselves, and then they also have alert pins, for PSU extraction or PSU presence. But then, the SMBs are also run to the Sled. I don't know for a fact, but I think the physical address here, which is kind of hard coded on the backplane, would have some play in what SMB addresses use.
Is there also
Power supplies that we
1
need
gig
back.
Ethernet?
Yeah, it's
1 gig E? Okay.
Yeah, it's 1 gig E running to all the Sleds. And SMB, the system management bus is kind of a backdoor that hasn't been developed yet.
Okay, so but at a minimum, you'd have to know the credentials to the login
Yeah,
credentials.
the addressing scheme, whatever.
Yeah, to the BMCs and the Sled.
So I want to ask a kind of different question. So let's say you've got all of this gear. You're putting it out on the edge, right, in all these different locations, right? Colo providers, whether you own the physical building or not, you're using a colo provider. So you've got all this gear out there, and now you have to manage it all, right? Typically you manage it because, hey, somebody called in and there's a failure. This is typical IT, right? Somebody called in, there's a failure. Now you got to go troubleshoot it, right? You go through your 100 different steps that are all manual-driven steps, right? How to troubleshoot, triage the nodes, do everything else, right? The one thing you got to know is that the number one failure in all your data center is actually not any hardware. It's human, right? So if you look at kind of, because I look at this from a little different angle of managing all this equipment out there.
Most of these edge sites will be unmanned data centers.
Correct.
So
Yeah, absolutely.
little
Absolutely. It's more complicated if you're all this edge and you're putting it out there in all these little places all the time, right? But you still have to manage the fleet of the equipment, right? It's fleet management, right? So you look at kind of where IT is at today is the typical large IT guy can manage probably 50 machines per IT employee. Right? So what's your average cost per IT employee? Just give me a ballpark. Just average annual salary. Just salary alone. Let's say $100,000, right? Basic cost. So your cost of managing one node for 1 year is $1,000, right? Now, if you're $150,000 per employee, it's going to cost you $1,500 per node per year, right? So people have solved this problem, right? There's a few people who have solved this problem really well. How many machines can a IT person at Google manage? 10,000. 9 cores. 45,000 nodes, right? It's huge.
I saw it was 25,000.
Okay.
Yeah, and it's all through automation.
Facebook's at 26.
Zero touch automation.
Microsoft and AWS are 32,000 machines. Google is at 40 to 45,000 machines. They've been developing their own tools to manage all this infrastructure, right, for 17 years.
Yeah.
Right. They're 10 years before where AWS and Microsoft started building their tools, right? And Facebook's been much earlier on in their development with their sort tool. So you look at the capability of where they're at. It costs Google $2.23 to manage one node per year. Right? It's crazy. Right? But they built these tools to automate and orchestrate all of the manual efforts that go into keeping the lights on into a data center. Whether your data center is remote or not even makes it more complicated. Right? How do you send somebody out there to go fix that machine? And if you send them out there to fix that machine, chances are you had a whole bunch of people trying to triage that machine to figure out what the problem was that guy needs to go fix. Right? And chances are the people triaging it caused problems while they were triaging the machine not knowing what they did. Right? Humans are the number one failure. In fact, so the guy at Google that developed their automation orchestration tool is one of the advisors of us, right, and what we're doing, right? So we're building a similar tool to that. But I asked him, at your efficiency level, what's your number one failure item in a data center? I was sure the answer was going to be hard drives or DIMMs. I was positive at managing 40 to 45,000 machines per IT employee. I figure humans is the least of your problem. Humans is actually still their number one cause of failure in data centers.
Yeah.
It's crazy, right? I didn't know humans were I knew we're all failures, right? But I didn't know they caused that many failures in data centers.
No, the problem is when they cause a failure, they take down hundreds of machines.
Yeah, well, and they mess up one machine so bad that they didn't know they messed it up because they're trying to solve something else. So they're not looking at the problem they caused. So that's something you got to go deal with later on. But the other one is also replacing parts in a data center. So you get told, go replace that DIMM, go replace that hard drive in that node. Right? A lot of times people will pull the wrong DIMM or they'll pull the wrong hard drive. They close the ticket and they walked away. Like, I did, right? Close the ticket. Problem solved. Well, you actually never solved the problem. You created a new problem, and now you got to go root cause the old problem again. So that happens constantly. So all of that functionality is how do you drive efficiencies managing all of this edge equipment when the cost of just people management of the gear costs you more than the actual gear itself.
Right. And that's where, I mean, all of our customers have been very much focused on automation, zero touch automation, zero touch installation. Redfish has actually been a really big driver for that too, creating, Ansible-based automated scripts for installation, maintenance, monitoring. The human factor of it, I guess until we get, drones that can fly out there and replace, the proper components, I mean, we're not going to get around that.
You got to think about the environment that you're in, cellular, provider, operator, cellular equipment, right? We're used to there being many cell towers, and there's not anybody around there, and this is
it's expensive to roll a truck out there to go do it.
The wireline is the thing. There's an ILA site every 100 kilometers on a long-haul network, and you don't have people.
We're installed at over 30,000 sites at each one of our major customers in the U.S.
It's much different problem than
120,000 sites total.
That's what I'm saying. It is way bigger. It is selling edge compute and managing that is more costly than a traditional enterprise, and it costs them a fortune. So how are you able to manage these boxes more effectively out of the edge? That's going to lower that cost because it's already costing twice the cost of the box just to operate for 4 years.
That you guys are working on something already? You guys have a?
We are, yeah.
Okay. Yeah.
Well, is there something you would do different in terms of the firmware? because here, I mean,
I could care less about the firmware, to be honest with you.
But
our product, we could care less about that.
But, well, everything that, if you want to know, if you want to gain telemetry information from your fleet, it all comes down to this firmware. And talk about the OpenBMC project. All the firmware that Google writes is getting shared into that project, right? RMC.
Not all of it.
Not all of it.
Seriously? You go try
I
to do it, try to
I
build it.
guarantee you it's not.
But the functionality is all there, right?
Yeah.
That all the firmware that enables that level of management, that lights out management, is actually available. And we're talking about the low level connectivity to make sure that we have the same types of connections in this that we have in your cloud data center.
Yeah.
So I guess is there, I mean, I think we're basically enabling that level of functionality in in an edge device.
Yeah, no, I understand from the hardware standpoint. I understand the BMCs, right? I understand, all that stuff, right? But driving efficiencies is a different animal completely.
Right. Yeah.
Right? And with the edge, it is going to be crazy inefficient because of all of the locations you got to put this stuff out into. Is far different than a typical enterprise, right?
Well,
and truck rolls
from
are
a telco
way expensive, right?
They do this today.
From a maintenance
that
point.
was
Oh yeah. It's crazy expensive, right?
Well, but forget about where they're physically located. It's still the same. You got the same number of IP addresses.
Yep.
Right? You're
that's
gathering
also
the
why
same number of same data points.
You design for no single points of failure. Right? I
Oh,
mean,
yeah.
the RMC being an exception,
does a
make
lot of
sure
that
that we
stuff,
have, RAID 1 drives, slight over provisioning of hardware, to handle server failures, redundant power supplies. We put all that in place just so you don't necessarily have to send somebody out immediately when any one thing fails.
I mean, the beauty about
that's over provisioning, right? So over provisioning is now increasing the cost of service, not only the asset cost of the box, right? So there's an efficiency level between operational and asset.
Increasing your CapEx at the savings of OpEx. Right? And the question is
Operational or asset efficiencies, yeah.
operational efficiency versus capital expenditure.
Which is asset efficiency.
Right.
So that's how
So there's a balance there.
Yeah.
How much extra hardware do you deploy to save on your operational costs?
You have to cost can be amortized where operational expenses they're recurring.
Yeah. So if you
You
had
can't depreciate your time on the guy driving
totally
the
with
truck
you, yeah,
for 2 hours.
right? It's crazy
Right.
expensive. But if you had tools that could manage
your
that
development
effectively and
is capped.
that can manage the health of the node, whether it's identifying failures that need a human person or whether it's identifying failures you could fix over software, as well as orchestrating full service for that fix such that you're not causing any more problems while you're doing it, meaning you're doing the right things from that guy who's out there doing the truck roll, who doesn't know anything about the equipment much, other than he knows how to replace parts, right? But if you can orchestrate that whole person's job such that you can put an auto mechanic and have him go fix it, you can have an Uber driver drive out with the part and go fix it for you, right? Rather than truck rolling your own expensive person to go do it.
There's all sorts of studies, for instance, into augmented reality to try to, provide more information to the crafts to allow them to more effectively, effect repairs.
So all of those things I've said have all been solved by these few tools that the hyperscalers built. And Google's 50% more efficient than anybody else.
Well, they've been solved in hyperscale environments.
Yes.
Not in distributed environments.
Right.
See, I would argue back that the Nokias, Ericssons, Huawei's, they've solved those for distributed environments. Because they've deployed hundreds of thousands of baseband units and millions of radio heads worldwide, all in a distributed environment.
Well, and folks like level 3s
understand, but it's still a fleet issue. Whether the fleet's in these massive data centers or in smaller data centers, it's still a fleet issue, right?
You're different hopping on a Segway and heading out into the data center, or actually having to have a truck provision.
Correct. Yeah, but where you can solve things through software, you don't need a human to do it, and you're keeping the health of the machine higher. You're not only solving for operational issues, but you're also improving asset issues as well, right? You're increasing the usability of those assets.
I think we agree with this, but we have as a hardware organization, we have to provide all the same level of telemetry information from the hardware, so that the software community can reuse all that software.
Well, as a solution provider, we offer soup to nuts environment.
So when this
your
device
cell
should,
company wants to deploy a bunch of cell sites, and they come to you and they say, we want you to build this, install it, maintain it, and we're not going to do anything.
yeah, I think we're on a path that
That's services, right?
we're on a path that if you plug this hardware.
In this case, though, we're just talking about this is our underlying hardware, and like Mike says, we're replacing the radio unit that's in the cell sites today. So if you lose a radio unit, you're dead. So somebody goes and replaces that radio unit. This is the foundation for VLAN or vRAN, Cloud RAN, where the radio access nodes are distributed among the towers, so that you can actually lose one of these boxes, and the calls keep going off of that tower because they're using another, so in a cloud type environment. So that's what these are for, to help with that. Not really. In some cases, it's a FCC reportable event that you've taken out X number of subscribers.
Correct.
Right? So you may want to change your environment from radio node to Cloud RAN simply because it reduces the cost of your filing and the visibility of your outages as well.
Yep.
Right? So that's what these, that's one of our use cases for this unit.
Yeah.
Not the only use case for this unit, but this is one for us.
Yeah. So at the end of the day, it's how do you get more machines managed per individual, right? Because that ultimately drives down, lowers your overall cost of the solution.
Your service availability at 100%.
That's just as important,
right.
And that's an asset
If
efficiency.
you can't buy enough equipment to keep it 100%. There's some failures that you can't have.
That you can't deal with, no matter what happens when they're out
Exactly.
there. Yeah.
Exactly. You can't have two nodes. We could do that with satellites. You can't do it with cell phones.
Yeah.
We're probably going to have lunch coming in about 20 minutes.
Totally with you on that.
Maybe we want to work our way through the rest of the presentation.
Lowering
and
costs.
that'd be a good break for lunch.
Yeah.
Well, and then we'll continue our talk in the afternoon. All right. So the rack installation, we do have a rail kit that comes along with it. This will also be OCP accepted. It does fit into any EIA 310 19-inch compatible rack. The depths are from 450 to 750, so it will fit in a typical deep rack as well into a much shorter rack. We do have little pins in the back that make sure you don't shove the thing back into the rack, that it mounts flush, and then your mounting holes will secure into the chassis itself. And then we do have lugs on the front. I believe we also have lugs in the rear for grounding if you so desire. I showed you the different configurations that are supported. Operational specs, this is really what I think differentiates us from a lot of dense compute solutions out there today, right? Operating temperatures to 45C. Short term to 55C. This is per GR63 core, right? official on that is, like, it's like 1% or 2% per year can be up to 55C. But the rest of it is, can be steady state up to 45C. Then all the EMC specifications required by our telco customers, and then the safety specifications and seismic zone force tolerance. We will be we'll be testing our own systems for that, and we expect anybody that creates any sort of follow-on sleds would also do similar seismic testing.
What about NEBs? So is there NEBs? So what if there's a NEBs requirement?
Yeah, this is NEBs, seismic zone force.
I meant from so let's say, for instance, I provide you a sled. Who's responsible for that system level NEBs, or do you want the sled to be NEBs ready?
Well, the sled will be, so the chassis will be NEBs ready. Right? If you have a sled that you want to NEBs certify, I think that's really up to the individual manufacturer to, arrange with the, who are the guys that do NEBs testing? We've got our facility in Plano that, NTS, or, the National Testing Labs, the National NTL. And then acoustic and, fire resistance all per GR64. I mentioned this earlier. This is just a couple of examples. A couple of examples of existing cabinets that fit the BBU form factor that will also accommodate OpenEDGE. Right, so that's really a powerful solution for our customers to allow them to potentially, if they have something like a dual street cabinet that they have an extra 3U in or 6U, they could turn that into an edge data center simply by the addition of the OpenEDGE hardware. And then our plane contribution. So the OpenEDGE project itself, we're really dealing with, but not exclusively involved in the dimension, the power budget, cooling, and the network requirements. And as mentioned before, the chassis is being submitted for OCP accepted. The server is for OCP inspired. A little bit of intellectual candy to try to spur innovation. And our timeline, we have released, what we're calling the 1.0 specification. It hasn't been formally approved as a 1.0 specification, but that's what we've titled it as. It certainly has to go through the incubation committee, be reviewed, and formally approved before we can officially call it a 1.0 specification. Right? I assume that would be the process for doing that.
Yeah, I'm just trying to think of what the status is
On
the spec.
So the last call we had, we agreed that we would have the workshop. We've not had any feedback other than one figure change we had mislabeled. And so this afternoon, we're going to go through the specification. Following this, we're ready for the IC, and unfortunately, you did the IC on the 7th instead of the 14th. But yeah. So we'll miss the summit, but we'll be, we have now, 6 weeks essentially to get all of any changes from here made. We'll do another last call on the workshop.
That could happen before the summit.
Well, no, there's not an IC meeting.
There isn't an IC meeting, but if the whole process is that you're supposed to present to the IC, right?
Yeah.
And I think we would like you to present to the IC.
Oh, yeah. Well, no, we got to present, and then they have 2 weeks to vote on it, and then, but that's where we are. We're ready. This is basically a last call.
Yeah.
For,
I think this
the V1 spec.
So if we roll that back, we would have to have an IC meeting by the end of February.
Right. There is no more now. The last IC meeting was last week, Thursday. So I know the IC is also really busy right now too. So,
Yeah. No. That's okay.
I think you'll miss the summit, but.
Yeah.
Well, we definitely
will. But we will certainly have it. We will certainly have it where it is ready ready for submission with any changes that come out of this meeting or the next call by the summit.
Right. So at this point, modified timelines, we still plan on placing the, once the spec is approved, placing the material on the marketplace, hopefully sometime during the first quarter, or maybe at this point it might be early second quarter.
Yeah, it could happen concurrently with the spec approval.
Yeah.
Yes, certainly.
Yeah, we've got all the legal documents are done for the marketplace, so all we have to do is add it to the agenda and we're done.
And then we'll probably release the 1.0 specification, and then following quick on the heels of that, based on feedback from this community, we'll have a 2.0 spec release. And if it doesn't vary at all from the 1.0 spec, then we just uprev it.
Yeah.
Yeah, that's a good one. Okay, so that's pretty much the end of the presentation. Okay, so we're about 15 minutes out from pizza. Well, we had a bit of a snafu. We actually had the really nice Mediterranean meal ordered.
Yeah.
Except one person thought they were ordering it, and another person thought another person was ordering it, so ultimately it didn't get ordered. So, pizza.
Thanks, pizza.
So, I think we're probably all due a nice 15-minute break before we eat. So, why don't we just adjourn now? The pizza should be coming in about 15 minutes. And then we'll, look to get going again around 1 o'clock. Good. Sounds good to me. If you haven't had a chance to take a look at the hardware, please.
Yeah, we're better fondling hardware.
This thing is extremely modular, extremely easy to put together.
Well, that's our learning from all the racks. It's amazing. That's what we did.
It does not come out. Yeah, it's not coming. This mic, I'm not able. It just doesn't work.
Yeah, the only thing I'm really not like about this.
Oh, it's not the iPhone one? Or it's okay.
I have it in the car.
Just try to get those replaced. Try to tell you all. So do you think here what we call the
I think with the 2.0 you get 100 gig. You get a standard 100 gig port, right?
Yeah, before you explain PCI delivery, so
so you have to go to the GS3. No, I'm sorry, you have to go to the better environment and better health. Okay, and then what they were for is okay. I saw some.
Really?
Oh, yeah.
Oh, yeah, yeah. You don't mess right? Yeah, you don't mess around. They're not that expensive.
No, they're not, no.
See, the reason they have shipping after so many uses, like that, they're not watertight, in there, you can buy it. Always.
I've heard of some people reusing them. When I was in my before they built one they had
Crazy. They had to roll out.
exactly, yeah. But they had two of them, they did. One was a new one, and one was a used container. Right? It was all beaten up and dented, you know, outside. Even when they repainted it, you could still see the dents and everything. You don't count it out. But they both lasted the same. They both lasted the same. Yes, they did replace the right? They did replace the old container. But that was nominal cost. And they never had vents built into there that they needed to replace. I don't think they needed to replace any of those.
Have you invested in the that's where the edge will pick up.
There's four of them.
I don't think they use it. I don't think they use it because they have breathability. Right?
Oh yeah, no. Because like until that was really drive.
Oh, yeah.
Well, the heat things drive real field. Yeah. Yeah, they can use the air, but
you got to let the air.
Pressure, they just so as long as you're blowing the air, the hard drive will be fine. Because hard drives, they're up in planes, right? And they'll be able to provide altitudes,
They're high reliability.
We had, I don't know, Sun had the same problem.
Oh, you were in Brookville there. Because everybody but the top 10 OEMs, you learn a lot about how these hard drives are made, work and stuff.
Well, yeah, I remember. Seriously? Oil on the
So it was the bearing, because they were metal bearings,
right?
And they had seals on those
Right, but I'm only hardware. That generates some alert, which then feeds back into the system, which then triages those alerts down some root cause, which may be a lapsing error or that failed and the automation restarted in the cloud somewhere on the other machine. And it could fail or that one failed, it's failed. So it's not just the hardware though, it's the whole, the whole entire service from cradle to grave. So we're doing version of that. All more modern. Yeah, all of this. It's all brand new. I mean, it's like
You can bring a small bed to find a phone.
Anyway, it's grown. It's a modern.
Yeah, right.
And they,
you wouldn't be working every day if you were.
Most all of the data centers that we work in, basically, our team will come in, do the site survey, figure out they can roll over 6 millimeter off. And it's like, because the operators have right? So they don't have site people. So basically, we come in, install it, and load the OS. So they're always cloud operators. decommissioning. It's the exact same, it's the exact same flow. Bringing up your cloud operating area. DNF as it is to replace your server. Put it in inventory system, put it into the cloud system, make resources available, and then bring it up. So it's no different. So if you can't, we bring up, the guys on the site are only there to plug the thing in. Plug power. Things off site, it doesn't require the guys to like, now hardware is because we got all the inventory and stuff, and we know where it goes, all that stuff when it's built.
We're trying to simplify it, so you can cheaper
Well,
to go install it, right?
So if you look at it from, say, from another standpoint, you already have installed things.
Thank you so much.
Okay? They're paying you some amount of money. So if you can lower your cost of goods, that increases your profit. Because you don't have to tell them I have new tooling underneath. You just have to make sure you trust your new tool against your liquidated damages charge. Right? So that's the, and I guess you could go have some insurance policy. That's just another cost, right?
Just be your lawyer,
Hey,
push back, and it costs you more to go after.
Nothing simple, man. Nothing simple with this telco.
They complicate the hell out of it. Absolutely. Absolutely. I would deal with them a lot when I was at
She's gonna kill me. Telling my
丸穴が開く、丸穴が開いて、そう、右側の方が、クエアの形でリセットがあるじゃないですか。丸穴が開いて、形としては、丸穴を切ります。丸穴と、リセットがついてるコーナーのちっちゃい穴。Reasonable. 今日、今朝のメールで、穴の進行がこの前のしか
I'm also about to think about my retirement plan. Yeah, I'm going to YouTube.
He's now at Supermicro after Getman Son laid everybody off or whatever.
Yeah, a while ago.
Yeah, he went to
Actually, I looked at
that was memory people, pre-NVMe guys.
Carolina.
Wozniak, their CEO. Facebook used a bunch of them. It's PCIe memory. Yes,
Then they started talking about waterfront, they're like,
So, you know, Peter Heffernan and Brian
okay, I can have a house on the water for $800. I'm in.
they were all-time guys.
It's just getting cold. There's a lot of it. Holy moly, yeah. You guys have to heat a lot.
OEM solution.
So it's one of those, it's like, oh, it's
Yeah, it's 2011. That was the first one. Right.
Yeah, oh, I see. He did work at Oracle for a while, but
Yeah.
so then he went from
Short
Oracle.
period of time, for 1 year.
Yeah.
And then he went to System Innovation, Subproject, Fusion IO.
Yeah, Fusion IO.
They got acquired by SanDisk.
Oh, Fusion IO, yeah, Fusion IO got acquired by
Like about got under,
yeah, oh, I
at the time that Western Digital
oh, really?
was
So
acquiring
Western-
HGST.
Oh, I see, yeah. Well, I used a bunch of the Fusion IO, that's how I met Todd.
Yeah, those,
The PCI.
PCIe flash cards,
I got
Yeah.
a little bit.
Yeah, I don't think
This adapter.
NVMe before
so he worked with all the Netra teams, which were all these guys here that we know, like Pochang, right? Pochang, Brian
Like a square,
Conroy, Michael McNerney was there, and Natalie Mann.
so basically, when
These are product managers for the Netra product line, right? Rob Ludeman,
for the adapter, the left, and the right is
Gary Winch,
for the square area.
technical engineering.
Right.
Well, I mean, Mock was also
Well, we are not
in the
looking
Netra
for
group.
90 plus, but we are looking for the one that Jeff designed.
Peter Heffernan did
So
sales
I
in the
don't
UK,
know why this came out, but we
now
are
at SAP.
yeah, that's a kind of full.
Yeah,
Design. I don't know. I think that's the case.
Keith was over there.
Where?
Yes, I know all the Netra guys that were over there. I don't know how if any of them are still there though.
Not it's full.
Like all of them have gone somewhere else.
That's what I have to go through.
Oh, yeah, sure.
So,
Looks like it's changed over quite a bit.
right. Then
Any of them
Jimmy,
there.
operation needs that information
Yeah, why not?
then to get
Through the Oracle and the
this information that you provided. I
Natural one.
cannot do anything, right?
No, I think Oracle started.
I don't know if
away
this
from
information is right or not.
They
We
started
we
pushing
did
away
that
from
with
telcos. They started pushing away from HBC too.
yeah, level 3 was.
Yeah, I know, but we are developing a new connector adapter.
And none of these guys are still there.
And I was wondering whether we should
Yeah, we
have
built
a
a
soft box of adapter connectors.
And by soft switch, only PBX, SF7.
But I have a
Soft switch is the only on-tandem soft switch that's FCC approved for use in telecom.
Really?
Yeah. All built off of Netras. And, before we had the Spark, like Spark 2s maybe, that you could get the case for, get too heavy.
Somebody else made it.
98, they made a case.
Oh, yeah, that was
Spark 2, no, you can rack mount the case.
And it nebized it.
Yeah, before the net.
Mike pushed it and nebized it.
Right.
Yeah, I remember that.
Right.
Get it done. And then Hunter came out and said, we're gonna go build our own telco grade chassis.
Right.
And pass the NEM certification and
Right.
all that good stuff.
So we used.
It was a profitable line.
Oh yeah, we used a bunch of them at level 3. Everywhere.
Netra was a profitable line. It owned the telco space for a long number of years.
Oh yeah.
Because nobody else had Dell or
No. Right.
didn't have any managed client.
Right.
And I was in the storage.
At least on the commercial, right.
We were building, storage group at Sun as well. So,
Yeah, so what you said is
Converging on an agreement on
storage people out there, making theirs and getting the certification so they couldn't sell them in telco grade environments.
Right.
No,
Meet that type of thing?
The J-Pod. You can take a lead. J-Pod.
They're moving too slow. No. I managed J-Buds and Flash products when I left projects or.
Yeah. What I'm saying, OCP have designs for the J-Pod, right? We have one that's OpenEDGE certified. Yeah, 45.
Yeah, maybe I should have put it here.
CRU?
There are two OU.
Okay.
Right,
Yeah, a little wider.
We had a European for a,
Same height.
but it's in the marketplace. It's got 3 trays, with 15 drives per tray. So it's kind of like the same form factor as the server. Sorry, server has 3 servers per copy. The same way it's going to
Yeah, they just each pull out and they're all cabled up. You have service on both sides.
Let everybody know that we're.
Yeah, we service on this side, and then this one is actually flipped over.
We're not muting,
No lunch for you?
I think it's.
No, I'll grab something later.
On the same page, and then the other one's on the other side.
Yeah. And not a lot of people are excited about the piece of it.
Right. So when you pull it out, there's still lots of.
So when you're going back to,
You know, it's interesting.
This afternoon.
oh, you're flying back. This afternoon.
So we have an Intel plane.
Oh,
So that flies into every day from Arizona. One goes to Arizona, one goes to Oregon.
oh really?
So I can take a flight in the morning and then I get here like 8.
So, wait, one goes here, and one goes,
And so they have like 6 planes. So 2 comes from here, one to from Oregon to Bay Area, and then goes to Arizona also. So
right. Oh, okay. Oh, wow.
Right.
So it's like 52 people in the plane. So you can basically, so now by 5 o'clock I have to show up back again.
Right. Which
Flight
airport?
leaves.
San Jose or?
San Jose, on the other side of
The other side, yeah. Like
Yeah.
private. Oh, yeah.
So we're doing that.
So we don't have to go through TSA, we don't have to go anywhere.
Right.
Just show up, show your ID and get in.
How advanced can they put that? Like internal?
It totally depends. Like I have a friend who just realized when he landed that his meeting got canceled for tomorrow.
Yeah.
So he just emailed me that so he's going to fly back in the Sometimes you'll get the flight, sometimes usually within 2 weeks you'll find 2 weeks out.
Yeah. Is it normally full? 52? So I know you have a lot of locations like in Folsom and
So they only fly to Arizona, Oregon, Portland, Oregon, Arizona, and Folsom is Central. That's it. It's all on the west coast.
West Coast.
Now you're buying all these dwarfed by all the.
But the thing is,
they go, we throw people.
The IBM
Down there long enough, you know what it is.
strolling in, he would come over there and have to hard on the car. Hey, what you got? Oh yeah, I've got a HCA. He's like, well, why you got that? Well, it's called Poughkeepsie last night and said it was having errors, so we're replacing it today. Yeah. It's like, seriously?
That's crazy.
Well, only with 3090 though, 3081 we didn't have the capability to call home. Only the 3090 had the capability to call home and say, yeah, an IBM guy would come in with the parts and be like, oh, we were having a problem. Yeah, just take a few errors, it's okay. We've already migrated the data off of it.
Turn on the call.
Even though they have like.
Yeah.
No way. How did you say your buddies? Right. And so they
Right.
But they had
Right.
Yeah, I never that would ever turn on.
But nobody.
We go out there for meetings. Yeah, but you know,
But you would say that you lost, but you didn't. Right. You leased it IBM, right? Because at the end of the day, when you wanted to sell it to somebody else, there's all that rack of documentation of all the work that's been done on it. And if you didn't have that, you couldn't get nothing for it.
So
Yeah. Well, no, that was
metal
that was in. We went to the. We replaced that 30.
Not this coming September. Our next summit in Europe is in.
Tech call home feature probably struggle to get any kind of printed on.
Well, you know, that's the University of Alabama. So
We wanted to
we
do it
weren't quite as
in the
paranoid
fall.
about other
The
people.
problem is a lot of
It's like I'd rather have somebody,
you know,
come, hey, something's wrong.
Solve
Come
this
to
problem
fix
for
it.
me.
Yeah, I solved it for you last night.
Figure out how to do
Right.
it.
It's very expensive.
€2
It's crazy expensive. Italy's
Right. Want some pizza?
Yeah.
Yeah.
I want the small one.
No, those areas, I don't know how they're compared. I mean, the cost of living up there is pretty small.
Conference areas are really nice. It's easy to get in and out of.
Oh, yeah. Public transportation. I mean, I would live with the gas problem. Maybe a couple weeks. If I moved back east, I would absolutely love it.
Yeah.
It's so easy to go around and not worry about a trailer.
I mean, you were just there. We're trying to figure out how the letter will be in folder and.
Yeah, he's right there.
Normally, whether in October over there, it should be fairly okay.
That's what we're thinking too, it'll be beautiful, if anything, it'll be the fall, right,
Half of
autumn?
us are taking it on the ocean, and then the other half we're all trailering it.
To do it then, in October,
Yep.
timeframe.
That'll be fun.
So Craig, do you
That's,
have feedback from cloud customers also on
The
this?
problem is that,
What now? Do you have feedback from the cloud customers, how they're doing Edge?
they could only offer
On
Thursday,
this
Friday, or
platform?
Monday, Tuesday, we didn't wanna do it Monday, Tuesday, cause people will have to travel.
No, mostly it's
We like to have it like in the middle of the
telcos.
week, so that
I know.
we can have.
Right, so we really don't have any,
And that's
be
part of the
honest,
challenge that
we've
we're
not
having
had
with,
any,
Global Summit, which is, Thursday and Friday, it's hard because everybody
it's
wants to
been
do workshops,
primarily
things like that.
solution providers.
Like,
did Facebook provide requirements into this spec for? Well, that's what I'm saying, they're not, they haven't participated.
Yeah,
Why not?
Friday did.
They have an Edge
for
play.
all the bases at one time.
Well,
Where I would like
This
to.
time around,
so, not the Edge
on
play that
Wednesday,
is
Thursday, Friday, they're gonna do
5G
hackathon course.
and that replaces the radio.
How long?
They have
Yeah,
TIP.
but how long?
We participate in TIP, the Telecom.
Right, but
project.
the one, this platform you have, they have a play in it.
Platform will be,
They have a play, that's just that it's not their play.
A lot of customers
Yeah.
wanted to do like
Yeah.
events Wednesday
And but
night
this
or
is
Thursday
for,
night. Harder to do it on a Friday.
so,
Everybody's.
we talked to those around in OCP, we're talking about,
I'm talking about here,
19-inch
on a Friday.
solutions, not to be athlete, not so big.
What's the
So
longest?
if everything you
So
want
we
to
were
do,
like, oh, well, we've got this thing. that
Because
we can talk to
we've been talking to a lot of
customers
CSPs,
about. Yeah.
and they have an Edge play. But I'm just trying to see how much feedback did you integrate from those customers in.
But ours are all, we don't have, we
We
don't have as much, interface with cloud five as we do.
not as cold as Chicago though.
So what about
Oh, yeah. Six,
Okay.
the six, and all the other telcos worldwide. So I was just saying, like, there's one of the telcos in China, they need 100,000 of these units
So from.
for their 5G rollout next year.
Nice compared to Chicago.
Right, so all of our providers are in,
took a
so we've got trials going on all over the world with this particular unit for, replacing the radio.
They don't let the cold
To
fade.
be a cloud radio,
They're out in it.
radio, whatever,
I
whichever.
used to live there in
Some
Chicago.
people call it C-RAN, some call it the V-RAN. And so, that unit has a package, software package that runs that allows it to be a radio access node
I am,
or a 5G
I'm going,
passively MIMO.
I basically take
antenna.
once we got.
They'll replace
the
your
NIMO
existing LTE radio, access, so plug and play. Go on. I don't know if Mike had a picture of it. There's a unit that enclosure that can either be wall mounted or tower mounted.
So your requirements are driven by your plan or by US
Multi-layered and I just.
Worldwide.
for this platform?
Oh, yeah, all our platforms are worldwide.
The minute it turned 35, that was like awesome. That was
So if you want to change a requirement, are you guys the one who's changing the requirements for this or
No.
no?
Oh, no. See, that's where the OCP comes in. So we said, hey, well, we've got this platform, and we will submit it to OCP, and then we'll give away, all of the design files for the chassis and for all the sheet metal.
This is your contribution to OCP.
Yeah, the Gerber files and the schematics for these boards. Yeah, and so then that's our way of trying to give back because we sold a lot of the open rack servers, so we want to play more in OCP. We contributed a NEB, NEB's enhancements for the open rack, so a seismic kit for the open rack, so it'll be zone 4 seismic certified, EMI shielding,
negative 48 volt input and right. So you can basically go on any CO now. So we contributed those. And then for this, we feel that there's a lot of other, cards, GPUs, disk drive cards, whatever, that this server needs. And so it's our way of saying, okay, here's the playground. We got two servers, one U and two U, and that's all we plan to develop. So we then host that there'll be GPU ports, disk drive.
So you're using a PCI Express switch on the back, right?
No. It's all passive. Okay, it's all passive. Yeah, it's all passive. So there's a.
Scary for me. That's a long trip.
So this is the power board. So the power supply is plugged in here, and the rack management controller plugged into the Air Max. So then the Air Max, they then, fit together.
Okay. But you're not gonna.
Right. So then the Air Max passes each of the 5 servers, and the power comes out for each of the.
So you're providing power and management to it.
Yeah, and that's what we were talking about on the RMC. Is that on the RMC there's then an Ethernet switch, so you can talk to BMC on any of your. So this is all just passive though, or very little. I noticed there's some something here that's probably SM bus, and there's one here. So there's 2 active essentially. I'm sure they're the SM bus. Controllers, everything else. Oh, there's another one. So there's 3. Yeah, so one here, one here, one here. The rest are just passive traces. You get the power, 2 power in, and then the power distributed.
So for Gen 1, the maximum TDP on a CPU is 250 on a 2U.
Max TDP is
250 for the 2U, right?
Yeah, 250 on the 2U, 205 on the 1U.
And are you going to probably increase it with Gen 2 probably?
Well, that's up for discussion. We haven't gotten one out the door yet. But as soon as we get it, then that's what that's what the working group's charter is to, it's not ours. It's not our spec. We spend a lot of time talking about trying to explain what it is that we're providing or giving. We're giving as a version 1, right? But version 2 is up to this group. It's not. We're not dictating. We'll be following, right? We'll be
working with the broader people too.
Yeah, we're part of the working group. Obviously we'll have requirements for version 2 coming from our customers.
Correct.
Hopefully other people will
most of your customers is our customers too.
I'm sorry?
I said most of your customers is our customers.
Yeah. Yeah.
The Westie just had a little bit of damage on it. One of his windshields exploded, and one of his plastic thing on your top bridge had melted as well. That's a good replacement. But they're going to be averaging 8 to 12 times. Except my contenders, but. And for me, I can get her up to 45, 40, 45. I don't want to do that. We'll probably start in North. I don't want to spend that time on the ocean. I don't want to. Going up to Astoria would be fun. Well, it's 3 or 4 days on the water.
You're half a day down stream to Astoria. Then you gotta hang out.
Nice to meet you.
And then once you're in the ocean. So do these workshops have a lot of people show up in the afternoon?
Sometimes.
I think it's great.
It's innovative. We could always show up and ask.
Yeah, and where they slept before. And
I don't have a card right now. I think.
What's the channel?
Connect with me on LinkedIn and.
Yeah, we've actually communicated.
recognize it. And we'll, if, all of the design packages are open and you're opening those up, we'll give it an OCP accepted logo. And if it's just the spec open, we'll give it an OCP accepted logo. And that way you can market it as a true product.
Right. Yeah, it's just to make, but we were actually gonna be talking to me about the naked so all the way up.
Yep.
So across all
And that's,
boxes, yeah.
and the thing is that because it's, even though it is an OCP based, I don't know how open is it. Is it just on the spec?
Oh.
Or is it, do you have all the design files open? What are you exactly building with it?
Right.
Because anyone can download the spec and say, oh, I've got something on OCP, and I'm like, okay, how is that, And especially at Summit, we tend to actually have somebody come and present to the project group, because that's how most people learn about it. And then you come and present it at Summit, because then it's been tried and proven, and you're getting all the questions asked in the project group, getting it off after Summit. So
all throughout Georgia.
we've been kind of strict about that over the last 2 years, and saying, hey, you're going to provide something, let us know ahead of time.
Yeah.
Absolutely. And we're already working with Mellanox, and Mellanox is also delinquent in recognizing their product. So they're building it, but we're like, hey, come recognize it.
All right.
This project group is called the openEDGE project group. It started with Nokia contributing their Firmware product, and they are doing version 1 themselves, but they're looking for the server chassis. And there's Mike. So we can tell you more about. They're looking for a lot more input for Gen 2.
And there's 3 for sale, one in Georgia that all fresh one.
So you can see the server chassis spec that's open. They're coming out with their server spec. But if you also want to participate in the server,
You sent me that picture.
all the information is there. And so we'd love to have a different system built around the server chassis, right?
It's sitting in Benicia Harbor, and I met that one.
I'm going to
Total champ.
how the edge started design server to help them save all
Run it around, right?
out there. I tried to track CDI. Oh, we're good.
Like a well craft?
And we just talked about
It looks like a bird truck.
It's convertible.
29.
you get on a truck,
If you can see it, it's
Where is it?
an hour for the guy.
Benicia. There's a
Maybe
tire
also swap it. And yeah, it's frustrating because they're all contractors. They're somewhere around
29. Maybe Phoenix 29, then Benicia.
IBM and services.
It's sort of point where we're just trying to prove like market. I don't know if they're died.
About these servers, but they are tools design, right? So something like replacing
New motor.
hard drive, you don't require any screwdrivers.
New frames, 500 hours on.
Extract the drive up in the new
What do you
drive,
think that boat's
press it and put it back in. So at least from the time it takes to do a repair and pop yacht you need to bring with you. It's really nothing more than the drive.
Finding it, maybe you could put a tile on it, and, your code, try and locate it, right?
Well, we can do it. Just like
I know a lot of the guys that were
we've got a LED that we can link at least to identify
ourselves failure.
or the server with the drive failure.
Just happened.
Yeah. Well, see, when I was, when I first started at university, it was 1980.
No, the chassis has no fan itself. Okay. I don't know how much.
The National Science Foundation Network had just went. And so
everybody would get a brand or whatever. And NSF was really big on throwing in some. I don't know what it was.
Well, we have,
called Spark One, the Spark Station maybe.
Yeah.
Spark Station. Small guy, right? And I was the youngest person in computer center, and we had gotten a connection to the state sponsored Cray, and so the Cray had switched to Unico, so this operating system, so the Unix operating system. And so that was my first Unix login, but I became the Unix person because of Cray. People started getting these workstations. Be like, hey, workstation to the internet, so I could get to, or to the Ethernet, so I could get to the internet.
Then you started getting into a bunch of Sun gear.
Well, at that time though, you were, it was Sun, Apollo, Tech, the RT, RS6000. So it was one of those four, usually. Everything was predominantly Sun. And then I ended up buying then I actually bought a Spark Classic, which was the Spark Station after Spark 2 and whatever had gone on.
They use in the QR code. I'm on WeChat now. The problem is I have to keep constantly be on it, otherwise.
But from a home computer,
And then you have to have somebody who sign up.
Hold it sideways like a tower.
You don't use WeChat for a while?
Really? I use it on a daily basis.
Yeah, so you use it just for like talking to your family and
Not really.
They
Because
had
I
had
cut
those
full
purple
work.
feet
Because I cut
Mhm.
full
lay
work.
them flat.
Yeah, lay them up.
A lot of space, right?
You can stack them up though. You can have your drive, fuzzy connect drives.
I never knew. It's
Yeah.
But on a desktop, those are a lot of space.
Oh yeah.
So putting it up on the side.
The Spark 2 was nice though, because it'd make a nice monitor. Put it about high. You didn't have to have so many auxiliary. Drives and drives.
Oh yeah. They were individual.
they know that you're people in the United States.
Really? Because I'm still on there.
Oh yeah.
No, but you talk to somebody like quite often. For me, I've been starting to talk to people, but
The
it gets me
problem
off.
for you is a lot of people.
I took the
Thinking kind of.
mainframe
All the way.
and started running AIX 370 on it. And
So on the
before all
thinking
the
how to use the QR.
DNS,
I don't know.
So when you're on the front,
On the front, okay.
QR
we still had 3270 terminal and
On the
FCC,
first.
that craziness, right?
Right.
Where AIX, you would SSH or Telnet days into it, and then use your PC as an emulator, and you had ASCII environment all the way through. And that kind of, by the first semester that was in use, it ran as a guest on VM.
So maybe I'm
And the
not
guest
in
user
the most updated version. Which one?
of the VMs.
Oh.
Right, and so that was why they were okay for all the academic stuff. Okay, everybody wants to use it. So we just get real computers.
Do it right.
Is that you?
Well,
not going to scale.
I liked the IBM. It was nice. Pardon me. It was a nice computer. I mean, those days we had. It had 16 vector abilities, and
Never mind. Add your name
so
faster.
it was powerful.
Okay, let
It
me.
was a powerful machine in the days when computing power was proportional to the weight.
It wasn't very flexible, but it had a lot of power.
Well, it was nice though, cause you know, you could run VM, you could run multiple AIXs, you know, so I could bring up a test system for the new operating system. I mean, same as with 10K though, right?
The 10K, you could cluster
as well
together to act as one big machine, right?
Well, that, but then you could also slice it into, you know, what IBM called LPARs, or, you know, so you could have a logical partition of this machine. So I could have a test system and a production system.
That domain
Just a little bit less, you know, for me to play with, test out the new code before I dropped it on to, you know, everybody else.
Oh, absolutely.
Oh, yeah. You know, I didn't share my card.
About 250.
What group you in at Intel? State Center group you in?
Say it again?
State Center group you in?
I am part of the network product group.
No, we
So my card is not reflective. As of October, I was in cloud group, but I moved in, till October, I was in cloud group. Moved to the telco group.
Oh, just
Telco group is responsible
So they wanna know what
all the radio sites,
working with all the telco.
antennas. I'm talking with I am talking with the data center team, software.
We are part of this.
You know, we knew that
I don't
things were moving.
You have a card?
I don't, sorry, I didn't bring any with me. So I'll shoot my information, I'll shoot it to you. But we knew that
You can shoot me who you're talking to. It's under
you know, that's what we like to do. And what you're saying is probably about the fifth generation of initial what we, you know, and Chris the beat, or the fifth, you know, kind of we modified it in his team. Yeah. For the oh yeah, you can. Chris Berger. You don't have to take up anything. Christian.
Yeah, I have.
I believe he reports to.
Yeah, we're deploying. Yeah, we were commercial in December. That's all.
So this is RSD. John is RSD.
General availability.
I didn't hear
I know
that.
Chris is. Bill is smiling.
Yeah.
Probably 60%.
Okay.
Documentary about the Prime Festival.
Those are mostly business development people. I think so. Christian is.
I think he's more business development.
We should get started.
You know what?
Okay.
Architecture or
John is not architect.
John, yeah.
GM.
We did have a couple of new people
Send me
join.
shoot me an email if you can.
Maybe if you guys just want to introduce yourself real quick.
Yeah, it's funny.
Oh boy.
All right, and so this is the part of the meeting that I know everybody's been looking forward to, the document review of the specifications themselves. So we can, you know, at least the idea here is to actually go through the documents, at least focus on what we are, you know, are fully, you know, submitting as accepted, and just see if anybody has any comments or, you know, or modifications or proposals that we might be able to pursue. So we basically will go through, you know, this table of contents that includes the, you know, the rack and chassis specifications, the backplanes, pinouts. We might jump through some of this stuff a little more quickly than others. You know, the power, the PSU, the RMC mechanics, the cooling, airflow, and that's pretty much it. So the document itself said the main features of the submission is the 3RU height chassis. I know we had a discussion this morning about other, you know, other designs, a 2RU, a 7RU, but for this particular submission,
1U, 2U sleds, redundant power feeds, airflow in both directions, and that is a requirement. And I think Atkinson probably got it right, and it's for reverse airflow, it's just a matter of being able to turn the fans around, right? However, the thermal environments become quite different, right? Because now you're picking up from rear to front, you're picking up all the heat of that processor and transferring it to the front peripheral, right? Where the other way is much friendlier on the peripherals. Okay. Intended for limited floor space, varying thermal conditions, limited power feeds. Also, we need to have acceleration capability, especially for vRAN and MEC-based applications. Most of our vRAN customers are calling for some sort of FPGA acceleration, and then for edge gaming and edge analytics, the GPUs are also getting some attention.
So is it just GPUs, or do we just say accelerators?
Well, it's just accelerators. It can be anything.
It can be anything.
FPGAs, it could be ASIC, custom ASICs, anything at all. And that's really just a matter of, at least for our server designs, is what goes on the PCI cards. Right now, for anything that's done onward, you might elect to put accelerators on board itself, on the motherboard itself. That's certainly an option. The chassis design, 1U and 2U servers, rack compatibility, EIA 310, intended to go into a 600 millimeter depth. One interesting thing here is that we do have a front cabling requirement of 100 to 150 millimeters. So you can properly run the cables, up the side of the rack. We have seen that in just traditional rack-bound servers, we have had to recess the rails, back, 150 millimeters or so, to make sure that we have enough room for the cabling. All right, because a traditional 19-inch rack is not really intended for cabling in the front, right? It's all cabled in the back. I suppose we could just turn the rack around, mount the thing backwards. That might be another option where we wouldn't have to, mess with the rails. Well, the power supply, there are redundant power supplies that actually feed a power bus on the back of the chassis, and we'll get to that here. So, possible configurations, power supplies. This is kind of the spec sheet for the server. 400 watt for 1U, 700 watt for 2U. I think somebody had asked about higher TDPs for future use. We do still have this 400 and 700 watt limitation that we would run up against. Right. So depending on what you want to add to it, if you were say to add a 300 TDP processor to it, then it might severely limit the the peripherals that you can include. But there might be an application for that. Okay. Weight of the chassis itself, not heavy. Dimensions. Again, the key is the width and the height, or the width and the depth. I'm sorry. The height is something that we could vary depending on whether we want to go 2U, 3U, 7U. We covered this.
Excuse me, Mike. I got a quick question for you. If we wanted to build a sled and so forth, without having to redo the chassis, who's your chassis manufacturer? Do you know, or is that part of the?
Well, you could not go to our chassis manufacturer and purchase that directly from them. Okay.
So we would borrow one from you, or?
Well, they will be on the marketplace.
Okay.
Yeah. Of course, if somebody like, I don't know, let's say we win, we want to take this design and manufacture a chassis, you would be more than welcome to go purchase it from them, right?
That's right.
But like I said, as Archana said before, this will be going out on the marketplace. Hopefully, sometime in March, it'll be available for community purchase. All right. So here's something that I didn't have in the mock-up. These are the rails for the 1U sleds. These turn the 1U sleds into, or you remove these, and the two 1U sleds will turn into a 2U sled. Right, so this is a toolless design that allows you to go between 1U and 2U servers or 2U devices, as you want. Different deployment options for the 3U. And the sled mechanics. So we've, in addition to, by the way, all of this is out on the openEDGE wiki that you see there. For the sled mechanics and the chassis mechanics, all of the design files are out there. The Gerber 3D step files. I mean, all that stuff is all out there for you to load up and manufacture it yourself. And so it's all been submitted and it's all open. Okay, including the dimensions of this are pretty straightforward. The key to it is to make sure that we have compatible spacing and the compatible power connector and the extraction latch that's on the bottom. Okay. And another key thing is that the front panel of all these sleds do need to provide the necessary EMC shielding. Okay, as a matter of fact, we do have. I think I've got. One of the sleds is actually a blank. Right, and so even in the blank panel, we make sure that we provide EMC shielding for that. Okay. Vertical mechanics of the latches are here. I mean, they're intended to be toolless, easy to extract. I think for those of you that have given it a try, you'll see it's not difficult to do at all. The sides actually have guide pins. That's to make sure that that the connector properly aligns and mates with the backplane. And one thing for you guys that just got here, the backplane itself strictly has power and 1 gigabit Ethernet to the baseboard management controller, BMC. It does not have any sort of user plane on it at all. Everything is front cabled for this, and the idea for that is to really maximize the life of this chassis in the field. Right, before you have to go out and actually replace the entire chassis, we want to give them the opportunity to go through several generations of being able to set the cards and and maintain that installation.
Hey Mike, is it possible to make that any bigger?
Yeah, it makes bigger.
And this is the current version, right? I'm sorry, I had to talk to Mark for a minute.
Yeah.
Okay.
How's that?
Yeah.
I can do this too. But it's definitely a lot bigger.
Oh yeah. Oh yeah, I can see better now.
Okay.
I put my glasses on too. Double up.
So the chassis backplane, you'll see we've got the Airmax connectors for the control. The HCIs to the sled then provides up to 85 amps, rated up to 85 amps, which with a 12 volt power feed is, well within our 400 watt requirement.
say there was available?
Well, they're rated for 85 amps.
Yeah, but then you did some math or something and said something about the motherboard or the boards would be.
Something about that.
Well, I thought you said 40 amps.
Well, so it'd be about 30 amps, 33 amps at 12 volts for a 400 volts. And then, you gotta remember that the 2U server actually employs both.
But it gets power from both?
Gets power from both, yeah.
Okay. Yeah. So that 40 amp on the lower plug is that's more the limit. So 33 with the overhead to give you 40, because you got 85 on the top.
Yeah, I think we 10% derate or.
Yeah.
So Mike, let me ask you, if I create a compute module and a storage module, can I connect them together? Because I mean I don't have any PCI Express connectivity behind on the back of the system, right? So how if I let's say if I do a module and exact same module but only put a NAND in it, right? And I basically use maybe compute module that is also sitting in the same chassis, and I want the NAND to talk.
You would just need the front panel cable.
So just okay.
Yeah, PCIe over.
Just do a PCI external cable basically.
Yeah, like 100 gigabit back between the two.
But there's no flexibility on the back of the plane, right? Okay.
Nothing on the back.
Nothing on the back plane.
We've been burned by that too many times.
Okay.
And we don't want to make that mistake again. And even if you look at what OpenRack was, OpenRack version 2 was just power connector, and that was it. Absolutely nothing in the front. Right? So the only thing we did on top of that was just add 1 gigabit Ethernet for the BNCs, but basically didn't touch anything else.
Right.
Okay. So that's the pin-out connectors and the the sizing and width.
So, Bill, is there anyone we should talk to about the stack up on the board? Is there any expertise we should get okay, that looks normal, or
Do you want to?
well, I don't know, I'm just saying.
I mean, if you're
For these boards, so we've got the stack up for it. I mean, I feel comfortable with our guys' work, but we talked about working with the server group or the rack and power, but
I mean, you're
is that
certainly welcome
anything
to
we should get a
no.
nod on, or just not worry about it?
Not worry about it.
Okay.
I mean, if your design engineers wanted to sound it off of somebody, they could certainly ask about that.
Okay. Well, I think everybody's happy. We're all happy with it, obviously, but
Right.
Okay.
With power distribution, it's kind of hard to say. When they can really answer that question is somebody who's done the DC and AC simulations on it.
Right. Okay.
That might be a good question to ask, though. Let's say we, how are we set up to handle maybe the next generation where we have perhaps a more concentrated solution? Let's say we go to, I don't know if they exist, but let's say we go to 3,000 watt power supplies. Well, we increase the per sled density to 600 watts.
You can just change the copper on the inner layer.
Yeah.
Yeah, but I think you're going to hit the 40 amp.
But then
These guys are 40 amp and those are 85, so I think you might hit more of that would be your long pole, and obviously the trace is on board. But it'd take a little bit more than that, or
I guess you probably could ask your designers
simulate it.
if you want to use 062 or 094 board PCB. Go out, if you go 094 out of the chute, you got a lot of room to add copper later on, but you're also carrying the expense of that.
Well, yeah, that's the balancing act, right?
Right. Depends on how it's mounted. You could actually still go to an 094 board later on and just reference it off the top surface as your datum and allow it to move backwards 30,000, 32,000.
Well, so I think that's probably a good question to try to feed back to our R&D guys. You know,
Well, yeah, you say what the
roadmap for a
thickness
denser
today
power
is 72
configuration.
ounces.
What's that?
See the last line there, the board has 8 layers for power, thickness of copper is 70 micrometers or whatever. 2 ounces.
Yeah.
That sound good? Sounds good. Bill, I'm gonna say you brought that up.
Oh, jeez.
I'm gonna give you a bunch of shit.
I mean, I gotta come out of here with some feedback for our R&D guys.
Yeah.
They're not gonna think I did my job if I just came back and said, no comments, they're all good with it. Okay. So pin out for the PCBs. Backplane power connector. 12 volts, 400 watts for 1U, 700 for 2U. Fed through the HDI. Up to 85 amps. Press fit connector. One is the AirMax. That's what we have for. That's what we use for the signaling. That'll carry the the gigabit Ethernet, the slot ID, the system management bus, backdoor, currently undeveloped backdoor, and server extraction pin, and I think it's all here. It's all actually spelled out here. All right, so to go through physical address. Actually, the one thing I kind of like about this is, most BMCs, or at least the ones I've always dealt with, when you power them up, they come up with some default IP address, right? It's usually a 192, 168, something or other, right? What we've done is we will read the address and make that the last octet of the initial IP address, right? So all the servers don't come up and collide with each other having the same IP address, right? So at least they all come up with initial unique internal IP addresses, but then they can also DHCP or gain a permanent IP address however they want. That was actually a pleasant surprise for me the first time I powered one up, because I had no idea. I figured they were all just gonna collide with each other, and I was going to have to pull out 4 of them and get one working and then plug the second one in, but they actually did all come up separately.
Now you guys are using standard drivers for like the BMCs and all that, no special funky things for BIOS and drivers, or it's all standard ASP 2500 stuff, right?
Yep, nothing funky. We are funkless. Okay. So the gigabit Ethernet. This is the general purpose I/O signaling RMC, the Sled baseboard. This is the I don't know what this is. I/O indicates the status and airflow. Oh, okay. This is just a little bit of management or status information back to the RMC that. That can certainly be used to raise an alarm. Let's say you have all front rear airflow and somebody plugs in a rear to front airflow device. That allows the RMC to detect that and alarm on a condition like that. That certainly makes sense. This is the Sled extraction. it may be a little difficult to tell the difference between a server that's just died and a server that somebody came up and, pulled out of the chassis. So it'd be important to know the difference between those two. One you send technician, the other one you send the police, right? Sled presence return, RMC alert pin, there's the chassis intrusion pin. This is the SM bus that we have not implemented yet, the clock driver for that, and the physical location. The only thing I might have a little problem with the physical location is if you look at it, the address is only 3 pins. Right, so that allows really up to 6 devices, right? Because you don't want all ones, you don't want all zeros, right? So with 6 devices, that may limit itself for certain denser configurations, right? Where you might have say 10 servers per sled or 12, servers per per chassis. But at least we still have a couple of NCs there that we could define if we wanted to extend that at a later date. Okay, guide pins. Standard guide pins. Yeah, that's those guide pins are actually see here the guide pins are located in the back. That's for actually mounting the backplane connector, making sure it's aligned properly. Chassis power distribution. These are the 2 power supplies. This is the power connector for the RMC, and guide pins for that. And then the AirMax connector for the signaling, and then the power connector. Power feeds. These are AC or DC power supplies. We're currently speccing out a 2,000 watt version. I'm sure that could vary depending on what your applications are. If you had something that might have been a little less power intensive, maybe some sort of optical device or something like that might not draw as much power, you might not need as large a power supply. Power supply dimensions. Here, as I can tell, these look like just standard server power supplies. The dimensions, they look almost identical. I haven't tried plugging them into a rack mount server yet, but they certainly look like they fit. Same ones we use. Yeah.
Would the airflow also need to be reversible depending on the configuration?
Yeah, absolutely. Yeah, that's a good point.
Is there any requirements in the spec that that you have 2 different suppliers interoperate together?
I don't think there's any requirement for interoperability.
That would be an assumed. Would you want to put that in the spec? Because my assumption is that would be key requirement.
You're just talking interoperability of the power supply.
Yeah, I'm assuming there's some current sharing circuitry between the 2. Is there some current sense or voltage sense lines that go between the 2?
Yeah. So this is the standard. Here's the spec for the power connector. Right. I think we've got the full. Yeah. So we've got the full pinout definition for those.
Yeah, so see.
And I'm not sure. I think this is a pretty
S6
industry agreed upon specification. You're wondering about the next power, that's connector type, pinout.
6 is PSU, I share.
Yeah, current share.
wanna ask that question?
Well, I think that you'd want to put in a statement that it either, I mean, right now it's implied that it does, and if there's no requirement that if there's a requirement that they work across any supplier, then you have to specify that behavioral model for that pin.
Yeah.
I think the way that works is it's an analog pin and it varies the voltage based on the current loads, and the two supplies will, somehow work together to deliver equal current.
Okay. That sound like it covered it?
Yeah. Also, is there anything in the spec that says, do they have to match? In other words, can you use like a 48 volt input on one and, a 200 volts on the other?
Yeah, I don't know why anybody would want to do that, but I see, so the example that I brought has both power supplies in it.
I actually think it's fairly common to use one supply on the minus 48 volt because that gives you your UPS backup.
Oh, okay.
And the others would be on a separate utility feed.
Okay. I've not run into that, but that's, I'll make note of that. I mean, it makes sense.
Most of the sites I've seen in Net 48 only have courtesy outlets for the AC. Anywhere near the equipment. Might be different in the cell site. Like a CO, there is no AC anywhere. You get an A and B DC feed. Everything else is in the rectifier.
I ran across that in China years ago.
Yeah, well, I can believe that. Yeah. It's crazy.
Sled and backplane power feed specification. Minimum operating voltage 10.8, maximum 13.2. Maximum input 37 amps, over current 42. And about, scale that up for the 2U.
What's the maximum input?
Per sled?
Oh, there we go, 13.2, okay. That's plus or minus 10%. Got it.
Yeah. Yeah.
Is there any specification saying that the two power supply is active mode or one active, one standby?
I think that's actually controllable on a per power supply basis, or by your power supply.
But is there any specification that your power board that have to be user configured or auto?
I don't think they have to be. No, I don't think there's any requirement for one or the other.
So, for interoperability, that two power supply vendors, they may not have the same design to telling their partner, which is unfair. You have to take over my job. So in between, you have to some communication between two power supply from two vendors.
Right. Yeah, I've actually seen that where, we have one AC power supply that's always active, not configurable, but then a DC power supply, that we have for the same server can be configured as active, or active standby. Right. Okay, yeah, it's a good comment.
So I thought that the, active, active standby was actually controlled by the, in this case, the RMC was controlled by the firmware.
It's controlled by the RMC if the PSU supports that capability. Because I think what you actually have to do is you configure the PSU to be active standby, and then they need a presence or a signal path between or voltage path between the two of them to determine when one switches and the other one doesn't.
I thought it was handled through the, there's probably a PS enable pin on the PSU enable pin on the power supply connector that turns on and off the output from the power supply.
I didn't think the RMC would be fast enough to control that. I thought it was a kind of a shared PSU function.
It's pretty slow. You just need a 16 milliseconds to respond. Go slide back up.
Here it is. Standby enable output, active high. Output under certain load conditions with preposition. Yeah, there you go. We'll still ask the question, but I think it's covered in this one here, S5.
I'll scroll down a little bit.
Enable capability.
Where's that?
Oh, this is, hot standby enable. I'm wondering what about the control. I thought the control was between the two PSUs.
Yeah. Maybe that's a question: does it need to be described, the theory of ops on that? If it's standard standard type of feature, then we don't need to repeat it.
Right. Here's a PSU alert.
PSU alerts inserted when the power supply loses its input power.
Right.
But it takes a few milliseconds before the output goes away.
Standby, that goes to power the RMC. Yeah, I'll get some clarification on that, what the mechanism is for active versus active standby.
It almost, from reading that, it almost looks like it is enabled automatically, so you wouldn't have a choice.
I thought it was done that way, especially when I was looking at some rack mount designs with it's been a couple of years since I looked at that.
Well, if it was automatically enabled, then you'd have one supply that would always be active and the other, active standby. So you'd have all your load on, let's say if you had two utility feeds, on feed A would be, fully loaded, and feed B would be no load.
Right. Well, that could also be used for cost savings as well. You have a power supply that might operate efficiently at 80%.
funny you described that.
What's it?
Funny you described that.
How so?
Back in 12 years ago, I actually got a patent for that exact concept.
Oh, did you?
Yeah.
Do I owe you any money for that statement?
But I could, I'll have to look it up. I think it was called cold redundancy or something.
Check in the mail. Okay, where we were. Okay. Power feed, we did that. Grounding. I don't think this version of the chassis had the rear grounding pins on it. At least I glanced and I didn't see it.
Yeah, I didn't see it.
Yeah, but we do have provisions for both, front grounding and rear grounding.
Is that just the early chassis or is it missing something?
I think it's just an early chassis.
Well, it looks like it comes off. Looks like it comes off of this piece here.
Actually looks like it's a little higher. Oh, sorry about that.
Oh wait. There you go.
Yeah, it's off of that one.
Like right here somewhere. I wonder if it screws in.
Oh,
right
yeah, as
there
a matter of fact,
right
look,
there.
that is those are the screw holes for it. So the
Alright, so,
the taps are there, the mounting's just not.
Yeah, wonder if that might come in a box.
It could. I mean, you wouldn't necessarily want it there if you weren't going to use it.
Yeah.
Okay, chassis management. Hot swappable. This is kind of key. In the case the RMC is removed during maintenance operations, TSUs and all sleds will continue to operate normally. And so everything's hot swappable. 1 gigabit Ethernet. The SMB or system management bus interface. The sleds, they act as backup for simple housekeeping where it has no BMC. So this is an option in case you create a device where there's no BMC on the sled. Now the I/O pins are there, but it's all assigned for future use. Pinouts, we actually covered those in the previous connector chapter. TSU. Oh, Bill, this might answer some of our questions. I'll check that. Doesn't really answer the question. Okay, the key to this, the RMC PSU or RMC monitors the PSU sensors, temperature, input output voltages, fan speed, input power, etc. It can also perform firmware upgrades on the PSUs themselves. RMC mechanics. Mentioned the RMC uses a standard AirMax connector, just like all the other boards. Pinouts and pinout definitions. We kind of covered all this up above. The GPIOs, the Ethernet, the Sled ready, Sled present. Coolant. to that, front to rear, rear to front. Chassis does not have fans. The fans are integrated in the PSU. That allows us to maintain our front-facing maintenance only. Perforation ratio, 64.4%. No air filters. I have had a couple of customers ask about air filtering. That might actually be a good contribution to make to this. Would be some sort of front and rear air filter design. It has been asked. But for us, at least, anything that requires like a dust tolerance would be deployed within an enclosure that would either have filtering or a sealed environment with heat exchanger. Independent fans, airflow direction. Oh, that's interesting. Recommended that airflow direction is configurable also in the field. So sometimes site requirements are not fully known at the time of ordering hardware. So that kind of answers your question. I didn't realize that there was such a thing as bidirectional control of the fans. That makes sense.
So in this case, the mechanism to configure it is just physically reversing the fans?
Well, that's certainly one method of doing it, right? You can physically reverse the fans, but what they're saying here is that it would be recommended to have bidirectional fans. Ones that from the motherboard itself, from the BMC, you can control whether it's front to rear or rear to front.
Okay. I did not know there was fans that were bidirectional.
That's what I just said. No, I think that's a great idea. I thought there was some W. Carter that issued a patent on that a couple of years ago. Okay. Sled design, hot pluggable storage, and networking.
Seems like you need at least 3-wire connection instead of 2-wire build.
Okay, and environmental specs. This is actually the last
Burn a 4-wire fan.
4-wire. What it could do it is the RMC.
Yeah, here's the problem.
Burns your GPIOs.
There's also a direction arrow on it.
Yeah.
So what you would have power, ground,
PWM and tap.
fan spin rate,
Right.
and direction.
And 2, I noticed this one. The power supply has the universal red handle. I don't see the blue handle on that. It has a black handle on the other one. Do you need another minute to touch the red handle? But this one has a red. Well, it tells you whether it's a hot aisle or cold aisle. Right, so the fan fits right which direction it blows.
Oh, say that again?
See, this one's got a red handle.
Yeah.
That says the hot aisle. That one should be blue. Say cold aisle, or maybe that's one of those fancy do it either direction.
No.
Most of your fans will have either a red handle or a blue handle, so you'll know the direction.
I'll be damned, you're right. They're different arrows on here.
But that should be blue, not black.
So that's a good question. Even though the sleds can be reversible, what about the power supplies?
It says they should. Or it's recommended.
Well, did it say for the PSUs or just for
Yeah, both. Both. It says a PSU.
Yeah, PSU.
That last sentence.
Airflow direction is preferable. Okay, but if not feasible, then it's used. Okay, yeah, that's covered.
But we don't have language like the IETF, the should, must, shall. So I don't know what recommended means. Does that mean I have to do it, or I can just blow it off?
Should.
I will.
So I would think that you'd want to specify the color of the handles on this.
Okay.
So to add a table to specify the color, either black or red.
Would be interesting to see what like the, network group did. It's the same on network switches too. Their power supplies have the red and the blue handles.
I didn't know that either.
Yeah. Like any of your network switches that you have that. I've never worked with anything but an OCP accepted switch.
If the data center is designed correctly and the air blew from the front to the back.
Yeah, they always worry about it,
You
right?
have to worry about all these different things.
Well, sometimes you want to put your switch in the back, turn it around for cabling, things where that one came from. OCP doesn't make a difference.
Who would ever want to do that?
Well, put your management switch in the back because you got some cables back there.
Makes sense.
But like I said, only your decathlete has to worry about that.
Yeah, that's good.
Okay. And then down to the last page of the spec, environmental. Says environmental spec slightly higher than for data center server products, and also includes seismic tolerance. So plus 45C, and this is with the, for us, for our servers, it's with the recommended TDPs. Storage, transport, safety, fire, all for GR core.
So, Mike, do you know about the seismic tolerance? Has it been tested?
No, I thought that's why Kai was coming to Plano.
No, that's for the 36.
Oh, that's for the third. Okay, yeah, he did mention that they are. I think they're doing that in Unix.
Yeah. So, but the seismic tolerance, the GR63 core requires that you have a server running.
Oh yeah.
And not take errors. So I wonder if we can include that as a generic specification for OCP purposes if you don't have the...
Include that for anybody else that
you're going to have... Yeah, I think it's, I'm not sure how that works. Maybe we should talk to like Katsu or something about it. He might know more about 63 core. But I know you have to be running and you have to demonstrate.
Are we certifying the chassis? And does that include anything we put in the chassis?
Well, I'm saying like...
Or is it certifying just the configuration?
No, the OpenRack had to do that too.
Oh, I know.
Wait.
But the question is, when we move to OR20, do we have to go do it again for the new server?
Yeah. I would imagine.
Right. Well, but if you got it for the rack, then you wouldn't.
But why would it care if you took like memory error, bit errors in memory or something during the event?
I was more thinking about power connectors, network connectors, there's optical cabling, different servers that have different, maybe slightly different latch designs, do all of those stay in place during the test?
Yeah.
Right, so to me, it would be more of a configuration design, right, as opposed to...
Yeah, I don't know, I think we put a note in there about the GR63 testing.
Okay. How about something like...
I wonder if it could be tested with only the BMC. Well, we didn't want to do NES, Bill.
Well, actually, does that apply to all of Table 16?
Well,
I guess
no.
If I look at that, it says
the operating temperatures wouldn't. Well, it could.
Yeah,
I mean, it would because that's a server.
Yeah, have to.
so. I guess there's some clarity on Table 16 because it says
Yeah.
it applies summarize the key environmental and regulatory specs for openEDGE chassis and sleds. Is it chassis and sleds? Or is it sleds,
well, no, that's what I'm saying. So for the shake test on the seismic, I know that you have to have servers. We have to have servers and storage and power supplies running in the open rack, and then we had dummy weights in the rest of them to simulate the load. But then part of the test was that the server, you had to show that you didn't get any memory errors or CPU errors while the event occurred.
Yeah. Operational vibration and shock.
So so we can't say that these specs are not just for the chassis because they're for a system. It's kind of like those reliability things.
I'm thinking
99.9. Well, you don't know unless you tell me what application you're running. I can't tell you.
I'm thinking of the case with
5.9.
Was it EMC? Do you test? Because EMC containment, the enclosure can play a big role in that.
Right.
So you don't necessarily have to have EMC, a Faraday cage around your sled if you're using the enclosure.
Well, your sled has to have the front has to have the EMC protect EMI whatever.
Yeah, but the top doesn't.
Well, yeah, the top doesn't because it's in the enclosure.
In the cage. But if you tested it, if you
can't test it without it. In this case, you either have to have a blank.
You may want to add a sentence in there that on table 16 that the test is performed with the assembly of or a configuration of sleds in an enclosure or in the chassis.
Okay. Yeah. Okay. Because we had to do that for all of the OCP open rack servers.
Right. Yeah.
But I think that version 3 Intel spec says every menu for the open rack motherboard.
Oh, the Facebook spec?
Yeah, the Facebook spec, right? I mean, it's called the Intel version 3.
Yeah.
Right? But that has a section in there that says the manufacturer must provide a EMI shielding mechanism.
Yeah.
Which are pretty hokey. We try to use them. So our next generation has the perforation built into the front of the. The same way these have it.
Right. Okay.
But I don't know how that.
We got that covered.
Counted. Okay.
Just do that. Yeah.
Okay. Well, I believe that takes us to the end of the spec. Do we want to cover the server specification, even though it's only going in as inspired? I think that's worthwhile going through.
Well, what do we have a strategy on the APIs? Is it a separate spec? Is it a
well, let's look. Strategy on the APIs is product architecture, 2500, power, sled, chassis.
Hey, why don't you look at the AST section?
Yeah, I was going to say, unless it's there.
And on page 2, you need to remove the highlighted yellow text.
Yeah, so it's just the high level spec.
On page 2, it's the OCP license section.
Actually, behind the note, you can remove from the note that whole paragraph. Yeah,
remove all of that?
yeah.
Okay.
And I think, Bill, Mike, that's our responsibility as chairs when you accept a document. That's one of the things you're supposed to look at.
Yeah. So on section 6, chassis hardware management, there's two approaches. You could embed the requirements in here, or you can treat it as a separate document.
Okay, where were you referring to?
Oh, section 6. I think it's on page 26. 6.0.
Oh, you mean on the chassis spec?
Yeah.
Okay.
So this basically referring to our API discussion. How does one, what do we need? What's necessary and sufficient to create, Sled level interoperability?
Right.
And
hold on, let me get that one. What?
the question is, what needs to be defined to assure, and what's necessary and sufficient to assure Sled and enclosure interoperability?
Okay.
Maybe you could even say software / firmware interoperability.
So, Bill, what is that second paragraph note? Other than providing Ethernet connectivity, is not involved in the hardware management of Sled. Could that not just be turned around and said, note, I don't know, only provides Ethernet connectivity? Because there is no API. That it doesn't care what you do with your Sled as long as it can be done over Ethernet.
Well, the charter does basically say that it focuses on the hardware, but its space is not limited to just those items. So I think it's worth asking, is there any sort of software, APIs, what do we want to try to add to ensure interoperability?
So right now you have
Yeah. Oh, well.
So you have Sled 1, Sled 2, Sled 3, and then you have and so you can either talk to each of these. Here's kind of your choice. Right?
Well, no. Well, okay, but I want to say the RMC really you need to make two blocks there.
Yeah, there's a switch.
One's Ethernet switch. It connects only, and then there's the.
So that's the physical connection.
Yeah.
But because it's a switch, you can basically address each one of these, right?
Yes.
And so you could say, I'm going to manage this as 3 individual servers in here, okay?
Yeah.
And it doesn't even know about the RMC.
Yeah.
Or you could say, I'm going to manage it as a group of servers, okay? In which you have one IP address here.
No, you don't have that capability.
No, they're all separate.
They're really physically all.
It really looks like this.
Yeah.
No. You got it right there.
You got that right. That's the.
I know, but
that's the system bus.
Here, let me.
So it looks like
now you're real quick. The RMC really looks like this. RMC, you have
there'd be 3 lines, I mean, that's a,
And then there's lines directly to the PSU.
Yeah.
Right, but there's one Ethernet interface that comes in, actually a couple of them. They go to the switch, and then from the switch get distributed.
So but each of these has its own IP.
And it's really,
Right.
and it's really more like,
or its own Ethernet address.
it's really more like this.
It doesn't necessarily have an IP address, that's up to the higher layer data center management software entity.
It's really kind of more like that, where they each have their own individual Ethernet.
Can I try one time?
Yeah, go ahead.
Okay, so if I manage it, if I manage a, if I manage a
It's all
server.
layer 2, they're all hanging off the layer 2 switch.
Yeah, but see, I would do it like this, so switch, and then the RMC, so this is all a board you're gonna call the RMC. It's not an RMC, it's a board, right? And then this guy has a microprocessor, which in this case is the ASC2500, that drives these guys. Here you go. Alright, and then everybody goes to the Ethernet. Yeah. And then the Ethernet has outward 2 SFP and 1 HT. Right? Is that working yet or not? No, it doesn't change anything.
I think it basically looks the same as the diagram we had before.
Okay, I can just see it better.
Yeah, just bigger.
Okay,
Yeah.
so
AST, GPIO/S. No, we've lost our.
let's just ask you a couple questions right here. So, one of the redfish commands is get chassis ID. Okay? So, how do I,
So it depends.
if I want to get the chassis ID for this,
Then you send a redfish command here.
so I need,
It returns it to wherever.
so I need an IP address to this device.
Yes, yeah. Every device
This
has
one
an
would
IP.
have an IP, this one would have an IP, that would have an
Yeah.
IP, and this one would have an IP.
Right, that's what I thought.
And this one also has a console USB.
So if I say get power consumption.
Yeah, or
For this Sled,
yeah,
I can do that.
yeah.
You can do it from the RMC that would report the power consumption of the
Power
of the
supply.
PSUs, or you could go to each and every sled and get their individual power.
Okay, so.
The PSU
So
doesn't know how much power these individually are.
Okay, but there's, as part of the redfish schema, you can get the power, the aggregate power from here of all these devices.
Yeah, I mean, everything that's being sourced by the PSUs, you can get the sum total.
But it would be a redfish command
Yeah.
to the AST.
Then you can go into each
Redfish.
one of the sleds and you can get their individual power.
So that's what I'm saying, we need to understand what redfish properties are valid here, and which redfish properties are here. Valid
Right.
there.
Okay. Yeah, that makes sense. Because they won't always.
That's right. Yeah, I mean,
But then, it's
Well, no,
really just
they're all valid, they just may return no value.
Yeah, it's really just the RMC.
Right,
that
you can issue any redfish command to the redfish processor, and it'll go look in its database, and it'll return a null. I don't know that. If you were doing a query,
what you're
if you
really
were doing a post.
concerned with is the RMC, right? As far as the sleds go, those can be anything, right? I mean, we're doing a couple of initial compute sleds, right? But those will vary, as other vendors create cards. But what's static is really this section here. This section is what we should define: the RMC and its interface with the PSUs, and also its interface through the backplane to the sled.
Yes.
On the SMB.
On little status pins on airflow, front to back, back to front, you know, those
Are
sort of
those,
status.
how are those communicated?
They're pinouts. They're actually pinouts that come to the RMC.
So I think one of the redfish plans is to initiate a chassis power,
Okay.
power reset, right? Yeah. Cold reset. So that would affect all of these nodes. So that feature would have to be supported in each of those, although it's issued through here.
Right.
There has to be a set of products.
Okay.
So it's really focused on the RMC and what effect it has on the PSUs and the sled.
Yes.
Right. Not necessarily everything the sled's going to report,
Mike,
but
As
what
long
it
as
can
it-
actually monitor and
If I can go to that IP address, you can have anything you want.
Okay, Mike, go to the press fit pinouts on the server.
On the server itself?
Yep. Well, I mean, it should be the same thing on the, it should all be replicated on the press fit on the power board, which then is replicated. See, I don't believe you got that many traces, is what I'm trying to say.
Well,
Because you got the press fit from the RMC, the Air Max, not the press fit, I'm sorry. The Air Max from the
look, say we got 3 GPIOs for airflow, and obviously the PSUs.
the RMC pin assignment, and the power distribution board.
And this is the RMC connector. Right, so you'll see it has FM RMC GPIO. Right, so let's see. FM RMC GPIO 012. Let's got 3 of those.
Per board?
Sled 4, 3, 2, 1. Sled 5 present 4, 3, 2. Oh, okay. It goes the opposite way. This is the status that goes out to the sled that indicate whether the PSU-01 is present and whether the PSU, fan direction is front to rear. So that's not an indication it's
I'm
coming
saying
in.
I think that goes to the RMC.
No, it goes from the RMC out. See, it's these 3 right here. From the RMC to all the sleds. Right, and then we got all the individual single pins. Right, is the BMC ready? Right, that's going to come from the sled. Right, is the sled present? That's
And are
going to
those
come from the sled.
what kind of signal is that? Is it
Probably
GPIO?
active high. Sled present. Oh, active low. Okay. Also active low. Open drain. Sled ready. There's a pull-up resistor on it. So it's active low. So that makes sense. So for something like BMC ready and sled present, those would be ones that the RMC we should be able to report through a redfish plan.
Yeah. Right. That's one thing. There's only a few.
Yeah, there's not many. No, there's not.
Okay. I just wonder what that. I'll look.
I think I have a solution. I think in this base spec, all you do is you put in two statements. One is, in section 6, is that the enclosure must comply with the OCP baseline profile. And the second statement is the server sleds must comply with the OCP server profile. That's all.
So we say
Well,
the,
I wanna check my BMC on the RMC.
Right. Yeah, yeah.
To make sure that it actually speaks redfish. I'm pretty sure it does.
That would solve it.
what's your wording on that? The OCP redfish profile?
OCP server profile. And then the enclosure must comply with the OCP baseline profile.
Okay.
Okay, so now we're pushing. So now the openEDGE chassis spec has just pushed a requirement to the servers, to openEDGE servers.
Now, to the Sled.
Well, yeah, to openEDGE sleds.
Mm-hmm.
We've just pushed a requirement to them. Now, what if they're not a server?
Well,
What if they're a network switch? Do we say to the applicable OCP profile?
Well,
That would be ideal, but there's subsequent profiles that get released, and you have no. It would be. I don't think you want to put a requirement in on something you don't know about. And since those two profiles are well defined, and they basically it's just a very small subset of all the commands. I think it's a benign requirement.
Well,
but that's assuming there's a BMC present.
overcoming the redfish hurdle is a pretty big one, though, regardless of what you return.
Yeah.
You know, that's one of the things that was mentioned about the system management bus is that it's there in case you have a sled that has no BMC. So if you had no BMC, you would obviously have no redfish, and you would have to do some sort of, proprietary extensions on the RMC itself to provide the appropriate configuration and controls for the BMC sled.
So you could state that that server sleds which have a BMC must meet the
But I mean, Mike, let's put server. Yeah, server sled. Okay, server sled must comply with.
We just call it sled. Well, yeah.
Yeah, I'm saying
no, you
leave it
can't
server,
because
we don't have anything other than the servers right now.
you don't want to leave it open-ended, Mike, because there will potentially be network profiles and storage profiles. So you could see a storage sled come in here.
Right, which would be what's the sailfish, lionfish,
right?
No, it just
don't the one coming after redfish.
No, swordfish.
Swordfish.
Swordfish is the storage one, and SNEA is not doing a very good job on that.
Right. Okay.
And the network one ended up being pushed off.
So in the case where you don't have a BMC on the server, and you're doing all that same functionality through SMBus,
you would,
then,
you would push that Redfish API to the RMC.
yes. So that's the third statement that you may want to add, and then, and let's see.
Yeah, but we haven't, you know, we simply stated that the system
sure
manager
we
bucket's
can do
there,
what
but
we
we're not
got.
doing anything.
I'm pretty sure we can meet these right now.
Yeah.
That's our bigger
I think
thing
that's,
as well.
I think that's sufficient.
Yeah, okay.
We'll have to check and see what the baseline profile is, but surely that's just, am I here?
It's
Am I
just power,
zone?
it's power and ID. I'm looking at it,
It can't be much.
account service, the
And I'm
login
pretty sure we
data, the
got
chassis,
Redfish built in.
chassis
so-
resource, power resource, thermal resource. It says manager's resource.
Yeah, yeah, yeah.
Returns the
I've not done
resources in
anything
the
but
DMC.
IPMI on it in the command line.
Yeah, I think that's all.
I'll check the Redfish and make sure that it's there. I know it's on the servers. I haven't used it, but I'll check that too.
Now we've got a list. So no, I did my job.
Yeah. Well, we got some changes to the spec. We could do it. I mean, I'm more, Bill, the IC. Well, no, we've tried.
Well, they're, and what they are enhancements, right? There's no, you know, this section is wrong. It's enhancement clarification, which basically means fundamental spec itself is still solid.
Well, yeah, that's as good as we can do, right?
Yeah. I mean, I do care what the IC, you know, what we deliver to them, but more importantly, you know, is this a, you know, is this a universal spec that can be adopted, you know, globally by the industry? And I think that's the question we need to answer, and that's exactly what we want.
How do we answer that question other than we have some implementers in the room? Jeff keeps nodding his head. So,
yeah,
we won't know till we know,
We won't
right?
know, right, yeah.
Let's get some commitments for new Sled project, so we can announce them at OCP. Jeff, how many are you gonna be doing?
Well, we definitely want to do some, but as I talked about, you know, we need to kind of discuss what we're seeing from a pull-in from our customer base. Now, we would love to build sleds, but we want to make sure we build the right sleds that have stickiness in the network.
Well, no, Henry, are you talking to Sri or?
Yeah, ARM's another good option. I was actually talking to some guys at Qualcomm about that for a while. Yeah, they laid them all off. Yeah, no, just before Christmas, I got the email saying that they cut our project completely. But before that, they seem to be getting some pretty good momentum behind it.
Yeah, we actually worked up to the point where they got laid off. We were getting all their data. We were going to look at building an eval for them. Also talking to some customers to see what the pull-in is for their ARM. That was the biggest issue. ARM for Edge was not big. Yeah, maybe we can talk separately.
ARM for Edge was not big.
According to the Qualcomm guys, they're wanting to get into that market. The Centric, I think that's the name.
Yeah, I think that's
Centric. It's very data center specific.
Yeah.
But they wanted to do the same thing for the Edge, but there was no major pull-in from the customer base for Centric.
Yeah, exactly.
I think the one that we're most interested in is some of the GPUs, because we're an embedded builder for NVIDIA and Intel.
Any interest from the open power community?
I'm sorry?
Any interest from open power?
Well, so you have to understand the telco's mentality. Their bread and butter is moving data. They're not going to risk on new stuff. Even those CSPs are not doing that.
This isn't a telco-centric solution.
No, but this is actually going to be a telco.
Our first commercial award for this did not go to a telco.
that's what you're pushing for, is a telco-centric
Well,
solution.
that's
Right.
our home court. That's what we understand best.
I have a
By the
use-
way, the IHS market data came back and told us the same thing.
What, the telco is the focus, or?
No, not the only focus.
Oh, yeah, no, not at all.
Oh, yeah. We got
I mean,
that loud and clear. We've been trying to say that.
It's funny how we build all these edge products, and
We
it's
just
going to
hope this is
military,
a-
it's going into IoT.
I think it's smart cities, industrial
Yeah.
applications,
And then
mining, I
manufacturing.
mean, it's,
I think if we were to build a sled, it would be twofold. One is that we've got a specific customer for 5G, the hardware accelerator. I'd love to talk to you guys on that. We have the design. We're actually building out to it. Sled. The Xilinx piece that we're working on for virtual IoT would be another good one. Right. With it, which is an FPGA.
is that a 1U or 2U?
That's a 1U design.
Okay, good.
We're also making it into a 2U to add a common board on top of it to actually integrate the x86 portion within within one appliance up to 32. And GPU, of course.
Yeah.
And the hardware accelerator we're working on, probably something that we can do outside the
Go this way. Power supplies come in here and RMC there.
For security.
I don't know if the OCP summit would be too soon, but I think it would be a great thing for this ecosystem if we could have another equipment vendor announce that they will be producing a sled for this design, during OCP.
So we have been talking with OpenStack and O&M and some other organizations, and we desperately wanted to basically create a showcase demo for the keynote. And we probably could have done it with lots of different software ingredients, but we didn't have enough hardware providers.
Yeah.
Otherwise, we would have made this product that we would have put it on the keynote stage. Because the theme for our summit is open together.
Yeah.
We didn't have enough partners to showcase this.
Yeah, it
Looking at it from
would have been good for that
December,
residential.
when we do our regional summit, I know that they're talking about a VCO 3.0, right? The virtual, central office that they had demoed last October. Looking at doing a new version of it, but if there's other demos that we could do along with that.
Well, they have that residential
Yeah.
one now
I think
that
it's
would
called
fit. It
virtual
would fit.
central office.
Actually,
Yeah, that would be a good fit for this box.
that's so the R-Cord.
Yeah.
Was it R-Cord OPNFB?
Yeah, well,
that's
not the business and not
right.
the.
But that's the target for
Right.
that, and
Right.
we're talking with them about that.
Right.
But the whole, for us, we have to have that multi-vendor support to really showcase it.
And talking about additional sleds, it would also be a great thing if we had another ODM announce that they were going to be producing the chassis. Either by the global or the regional summit, right? So just to put some meat behind that, multi-vendor, multi-source arrangement.
We could probably help you with that, Mike, on the chassis piece.
Yeah, I was thinking about somebody, but
They would be perfect. So one thing that we did you go to the QBR with us months ago? And so it was a QBR, and our president was there, and my boss. And I think we basically said we will be your key partner on this product. So maybe at the summit we could make an announcement that we don't have a sled, but it's our intent to be a part of this full ecosystem with the Nokia openEDGE.
every little bit helps.
Well, I would like for it to quit being the Nokia openEDGE. Kind of gives me a little.
I don't know, they call it the Facebook Open Rack.
Huh?
Was it called the Facebook Open Rack? But
No.
yeah, Nokia openEDGE just doesn't sound right for some reason.
OpenEDGE.
Exactly. Yeah.
Lowercase open, uppercase edge. Feels like it. So on the ARM-based, Citrix is still alive in Qualcomm, just the people are gone. So maybe we could look together and figure out.
And there's starting to be, I think Huawei just announced that they were doing an ARM server, and I think even Amazon announced that they have ARM-based ASW or AWS.
Which is based on the Annapurna platform they have.
That Annapurna.
Yeah.
Well, no, that's the offload. No, but
No,
I think
they are using Annapurna
they
for.
actually have ARM-based processors.
No, so Annapurna is the ARM-based processor. They're using it for both purposes.
No. Is it also the processor on the
So their offload also has ARM cores in it, and now they're using that as an instance also.
Okay, so they.
Yeah, so it's just using it for
So
multiple
it's not
purposes.
just an accelerator. It's also.
Correct. It's actually used for storage, accelerator, and also for to host function as a service.
Mellanox. There's a few things that we can NXP ARM. Yeah. Mellanox before they get bought by Intel. Oh, somebody's going to buy them. I've heard Xilinx is going to buy them. I've heard Microsoft is going to buy them, and Intel's going to buy Mellanox.
I have no idea.
Probably the right answer.
They don't tell me what they do.
Somebody's buying.
So who's the kind of ODM like that besides Sled?
I'm not allowed to.
Oh, you guys are not
They
allowed
do
to.
it. If you're not allowed to.
I know.
Who your vendors are.
I know. SK Telco.
I mean, ideally down the road, I can't talk about my other AIPG groups. We might want to create an accelerator sled on this one. There might be other, maybe a storage kind of aspect we talked about with some of our ADFF form factor where other storage vendors can collaborate on that. So there's definitely opportunities. It's just that I don't have. We have to probably see some level of pull coming in that's driving that. So I'll follow up with you offline and see what we need to do.
Yeah, I think you could probably fit 4 or 6 of the cap rulers in a 1U design, and then maybe with an OCP.
Actually, I don't know. 1U I can fit up in this probably about 12, 8 or 12. The 2.5.
Are they 7 millimeter or 9 millimeter?
Still a 7 millimeter.
Are they 7? Okay.
Yeah, we need to check, but I think so we can in a 1U full we can put 32 of them.
Well, that's in a.
The full length, right? But I'm saying 8 to 12 is what I'm saying.
But remember, we're all front access, so
correct.
Your networking is also up front and interface, right? Like on that super micro design, yeah, you put a ton of them across the front, but then all your networking is in the back.
That's the design I did with them.
Oh, did you?
Yeah.
I don't know what this supports, but I know like the NIC 3.0 card has these more connector.
Yeah, it's made by Tyco or something.
Oh, no, it's actually
You know, it's central
Oh, okay.
you can actually do extensions and things like that without having to redesign your board for something perspective, right? So it's all stuff to get out.
Michael, I need to leave in 5 minutes, but the slides that you presented earlier, the first,
We'll post all of those out on the wiki. Yeah, I'll post all of those. I know that, we still have the server specification to go over, but that is really only an inspired submission, and that's also posted to the wiki. So, I would suggest that we, give you guys an opportunity to get on the highway before the traffic gets too bad.
It's too late. It's too late.
That's what we're making now.
2 o'clock is the...
Yeah, 2 o'clock.
2 o'clock.
Yeah.
Well, I'm just giving myself additional time to get
2 to 8.
Okay.
Sometimes it gets really...
You're in San
Oh, San Jose.
Either that or either 2 or 7.
I could do San Francisco before.
Well, we have our own plane. Intel has our own plane, so we don't need to fly.
Oh, I see. You got
so we go on the other side of the San Jose.
here and you have to get there by the time the wheel's up.
Yep.
Yeah.
Probably sleeping in the car a couple of times a year.
Yeah, I think,
Oh, I think we will. Thank you, sir. Yeah, thank you. And everyone, thank you for joining. I do appreciate it. Appreciate your time, appreciate your feedback, your contributions.
Look forward to seeing you on the call.
Yeah, definitely join the call. Look forward to seeing you at the OCP Summit.
Definitely will.
I know you guys always have a
Yeah,
booth there.
always.
I'll stop by and see you guys. So we
I am Arizona, but I'm part of the network part. Under this. So we deal with all telcos.
Yeah, we'll have
an edge and 5G.
And definitely Ryan.
Oh, I see.
Right. Oh, yeah. Yeah. No, I think we actually walked by you on the way to our booth.
I know you guys.
You will look me up and I come here.
I've seen you guys, and you bring in a lot of racks of equipment.
Alright, so we'll have a nice product.
Nice to meet you too.
Have a safe flight back. Hopefully I see you.
Yeah.
So it'd be a good opportunity maybe to set up a meeting and.
I work with DJ. Oh, you work with DJ? You know him, right? Pretty good. I relate to that.
Email me that.
Oh, you know the
You're located out
Thank you, sir.
There, you started a trend.
You are located here or from? Oh, Boston.
You guys,
Okay, so come here.
I've heard your name. I mean, since I'm new in this group, he's like a board operator.
He was a little bit of Oh, don't show us that.
let's support one hardware platform.
Thank you very much for joining.
I never understood what it is.
China,
Yeah.